What if the first great civilizations didn't fall because of war or invasion, but because the climate itself turned against them? Thousands of years ago, a series of dramatic environmental changes reshaped rivers, destroyed harvests, and forced entire societies to abandon the worlds they had built. In this video, we'll uncover the forgotten climate shift that may have changed human history forever, and the clues it still leaves behind today. Before we begin, don't forget to like this video, subscribe to the channel, and share it with fellow history lovers. Now let's travel back to the moment when nature rewrote the fate of humanity. The horizon never announces the end of a civilization. It begins with something far quieter. A river arrives a little later than expected. The spring grasses appear thinner than those remembered by the oldest farmers. A familiar marsh shrinks by the width of a few footsteps. One harvest disappoints then another. Nothing seems dramatic enough for people to abandon the homes their grandparents built. Yet century after century, these nearly invisible changes gather into a force capable of reshaping the human story more completely than kings' armies or monuments ever could. Across the ancient world, the first societies rise during an extraordinary period of environmental stability. For thousands of years, the climate settles into a rare balance. Temperatures remain relatively predictable. Seasonal rains return often enough for crops to mature. Rivers overflow within familiar rhythms. Forests expand into places that had once been cold or barren. Grasslands support growing herds of wild animals. Lakes fill, wetlands flourish. It is a world that quietly encourages people to remain in one place. That decision to stay instead of constantly moving changes everything. Small villages begin appearing beside rivers, lakes, and fertile valleys. Families invest their labor in permanent homes because they expect the seasons to behave much as they did the year before. Fields are cleared with enormous effort because there is confidence they will remain productive. Grain is planted with the expectation that rainfall will arrive when it always has. Granaries are built because tomorrow seems dependable enough to justify storing food for another season. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. What makes this transformation remarkable is how completely it depends on something that nobody living at the time can control. The earliest farmers possess remarkable knowledge of soils, seeds, animals, and changing seasons. They observe stars, winds, clouds, insects, and birds with astonishing precision. But none of these observations allows them to influence the larger climate itself. Their entire civilization rests upon patterns that seem permanent only because they have lasted for many generations. Modern science tells a different story. The period known as the early Holocene follows the retreat of the Great Ice Age glaciers. Massive sheets of ice that once covered much of the northern hemisphere gradually disappear. Sea levels rise as meltwater pours into the oceans. Entire coastlines shift inland. Vast plains that hunters once crossed slowly vanish beneath expanding seas. Even while the world continues adjusting to this enormous transition, many regions experience thousands of years of comparatively stable weather. Compared with the violent swings of the Ice Age, this stability is extraordinary. To people living within it, however, it simply feels normal. Children grow into adults believing that rivers have always flooded in familiar ways. Elders tell stories about difficult years, but those years remain exceptions rather than permanent changes. Generations inherit expectations about planting, harvesting, and migration routes for animals. Entire calendars develop around recurring environmental rhythms. Religion, ritual, and political authority often become intertwined with these dependable cycles. When the rains arrive, they reinforce faith that the world remains ordered. Yet beneath this appearance of permanence, Earth never truly stops changing. Deep beneath the oceans, immense currents continue carrying heat around the globe. The atmosphere shifts constantly, as volcanic eruptions changing vegetation and orbital variations subtly alter the balance of energy reaching the planet. Monsoon systems strengthen and weaken over centuries. Storm tracks migrate. Some lakes expand while others quietly begin retreating. These processes move slowly enough that no individual notices the complete transformation. Human memory spans decades. Climate unfolds across centuries. That difference becomes one of history's greatest traps. Imagine standing beside a broad river that has nourished generations. The difference between one year's flood and the next appears insignificant. A few more exposed stones, a slightly narrower channel. Perhaps elders remark that the water once reached farther into nearby reeds. Children barely notice. But after 200 years, the river may occupy an entirely different landscape. Civilizations rarely collapse because people fail to recognize one disastrous season. They struggle because countless small disappointments gradually become the new normal. Archaeologists see this process everywhere they excavate ancient settlements. Layers of soil preserve evidence invisible to those who once lived there. Charcoal reveals changing vegetation. Tiny grains of fossil pollen record forests retreating and grasses advancing. Microscopic shells found within lake sediments reveal whether water remained deep or became increasingly salty as evaporation intensified. Animal bones indicate changing hunting patterns. Seeds preserved in ancient storage pits demonstrate shifts from one crop to another. Every fragment contributes another sentence to a story written over thousands of years. What survives in the records suggests that climate rarely acts alone. Human decisions always matter. Communities innovate. Farmers experiment with new crops. Wells are dug deeper. Irrigation channels become longer and more elaborate. Trade expands to compensate for local shortages. Leaders organize labor to build reservoirs or canals. Sometimes these adaptations succeed for centuries. Sometimes they merely delay the inevitable. One of the most surprising discoveries of recent decades is that many ancient societies prove remarkably resilient. Popular imagination often pictures civilizations disappearing overnight beneath floods or catastrophic droughts. Reality is usually more complicated. Entire populations may endure generations of worsening conditions before abandoning their settlements. Houses continue being repaired. Children are still born. Ceremonies continue. Markets operate. Daily life persists even while the environmental foundation beneath it slowly weakens. This gradual transformation makes the archaeological evidence especially fascinating. There is often no dramatic destruction layer, no unmistakable sign marking the final day of a community. Instead, fewer houses are occupied. Public buildings receive less maintenance. Imported goods become scarce. Agricultural fields shrink. Eventually, silence replaces activity. Wind carries dust through streets where people once gathered. Plants reclaim walls. Animals wander into abandoned courtyards. The landscape remembers even after people leave. Scholars still debate exactly how much responsibility climate bears for many of these ancient transformations. The evidence remains incomplete because every region responds differently. A drought devastating one valley may barely affect another supplied by snow-fed rivers. Political conflict, economic inequality, disease and migration often combine with environmental stress in ways that no single explanation fully accounts for. Rather than replacing human agency, climate often magnifies existing weaknesses until societies struggle to recover. This understanding has transformed archaeology over the past several decades. Researchers no longer search only for lost cities or buried temples. They also study cave formations that preserve ancient rainfall patterns, glaciers that trap microscopic particles from distant eruptions, tree rings recording annual growth, and ocean sediments preserving changes in temperature and circulation. Together, these natural archives allow scientists to reconstruct environments stretching back thousands of years with remarkable precision. The emerging picture is both humbling and unsettling. Humanity's earliest societies do not simply invent civilization through intelligence and determination alone. They flourish because Earth temporarily offers conditions favorable for agriculture settlement and cooperation on an unprecedented scale. Civilization, impressive as it appears, grows upon a foundation that remains far less permanent than its builders ever imagine. Far beyond the first villages, beyond the rivers and fertile plains where farming begins, subtle forces are already gathering. Winds are preparing to shift. Rain belts will migrate. Deserts will slowly advance. Lakes that seem eternal will begin to shrink. The changes will arrive so gradually that few living through them will recognize they are witnessing one of the greatest turning points in human history. The climate that makes the first societies possible is quietly beginning to change. For thousands of years before the first cities rise, the Earth offers humanity a rare gift. It is not unlimited abundance, nor perfect weather, nor endless fertile land. Instead, it provides something even more valuable, enough predictability for people to believe that tomorrow will resemble yesterday. That confidence becomes the invisible architecture beneath every wall, every field, every granary, and eventually every civilization. The contrast with the world that comes before is almost impossible to overstate. During the last ice age, climates often shift with startling speed. Vast glaciers spread across continents before retreating again over millennia. Temperatures fluctuate dramatically. Grasslands expand, then forests reclaim them. Rivers alter their courses. Entire animal communities migrate across enormous distances. Human groups survive by remaining flexible. They travel with the seasons, following herds of mammoths, wild horses, reindeer, or bison. Permanent settlements remain rare because permanence itself is a dangerous gamble in an unstable world. Then, beginning around 11,700 years ago, global conditions enter a comparatively calm phase known as the Holocene. The violent climatic swings of the Pleistocene gradually ease. Temperatures stabilize within a relatively narrow range. Rainfall patterns become more consistent across many regions. Forests spread northward into lands that had once been frozen tundra. Lakes fill from melting glaciers. Rivers settle into recognizable channels. Although the climate continues to vary from year to year, the extremes become far less frequent than those experienced during the preceding tens of thousands of years. For early human communities, this change is nothing short of transformative. Instead of moving camp every few weeks, families begin returning to the same favorable locations year after year. Certain riverbanks consistently provide fish. Nearby hills offer stone suitable for tools. Wild grains mature reliably enough to justify harvesting them repeatedly. Over generations, temporary camps become seasonal villages. Seasonal villages slowly become permanent settlements. This transition unfolds independently in several parts of the world, a remarkable example of humanity responding to similar environmental opportunities in different places. In the Fertile Crescent stretching across parts of modern Southwest Asia, communities experiment with cultivating wild wheat and barley. In China, rice and millet gradually become central to settled life. In New Guinea, people manage highland plants in increasingly sophisticated ways. Across Mesoamerica, early farmers begin domesticating maize from its wild ancestor teosinte. Although this process takes many centuries, each region follows its own path, yet all share one essential requirement: a climate stable enough to reward patience. Agriculture is an investment unlike hunting or gathering. A hunter may succeed or fail within a single afternoon. A farmer commits months of labor before discovering whether the harvest will justify the effort. Seeds must be planted, fields maintained, pests, controlled, weeds removed, and irrigation managed long before grain can be collected. Every stage depends upon seasons behaving within expected limits. The first farmers, therefore, become careful observers of nature in ways that are both practical and remarkably sophisticated. They notice which slopes retain moisture longest. They recognize subtle differences in soil color and texture. They understand how frost settles into valleys but spares nearby hillsides. Birds arriving earlier than usual may signal changing weather. The flowering of particular plants indicates when fields should be prepared. Their knowledge accumulates not through written science, but through countless generations of close attention. What survives in the archaeological record suggests that this accumulated experience is often astonishingly accurate. Ancient farming communities select crops suited to local rainfall elevation and temperature with impressive precision. They rotate fields, manage water, and domesticate animals that complement agricultural cycles. Sheep, goats, cattle, and pigs provide meat, milk, hides, manure, and labor. Together, crops and livestock create resilient systems capable of supporting growing populations. Population growth itself begins changing the landscape. Villages expand as more children survive into adulthood. Houses become larger and more durable. Mud brick replaces temporary shelters in many regions. Stone foundations appear where suitable materials are available. Storage buildings grow increasingly important because successful harvests now produce surpluses that must last through winter or periods of poor weather. The existence of surplus food changes human society almost as profoundly as farming itself. When every individual no longer spends every day searching for food, specialization becomes possible. Some people devote more time to making pottery. Others become skilled stoneworkers, weavers, or builders. Religious leaders emerge with responsibilities extending beyond immediate survival. Trade develops between neighboring communities exchanging resources unavailable locally. Obsidian from distant volcanic regions appears hundreds of kilometers from its source. Decorative shells travel inland from coastal environments. Pigments, ornaments, and carefully crafted tools move through expanding exchange networks. These growing connections create benefits that reach far beyond economics. New farming techniques spread from one settlement to another. Plant varieties adapted to different conditions gradually circulate across wider regions. Ideas travel alongside goods. The earliest foundations of civilization are built not only from stone and mud but also from cooperation. Yet cooperation carries hidden risks. As settlements become increasingly dependent upon agriculture, they also become increasingly vulnerable to environmental disruption. Hunter-gatherers possess remarkable mobility. If one valley produces little food, they can often move elsewhere. Permanent farming communities enjoy greater stability during favorable years, but that stability comes at the cost of flexibility. Houses cannot simply be carried away. Irrigation canals represent years of labor. Orchards require decades to mature. Granaries filled with harvested grain tie families to specific places. The very success of agriculture creates dependence upon landscapes remaining productive. Some communities recognize this vulnerability and invest enormous effort in reducing uncertainty. Irrigation systems extend water beyond natural floodplains. Terraces carved into hillsides prevent erosion while conserving precious moisture. Storage pits protect grain from insects and rodents. Livestock serve as mobile reserves of wealth that can be moved during difficult years. These innovations demonstrate that early societies are anything but passive victims of nature. They constantly adapt to changing conditions. Even so, adaptation has limits. A canal cannot deliver water that never reaches the river. Terraces cannot preserve crops through decades of relentless drought. Storage pits eventually empty if harvest after harvest disappoints. The remarkable ingenuity of these early communities allows them to withstand ordinary environmental fluctuations. Extraordinary changes, however, demand solutions that no previous generation has needed to imagine. Meanwhile, the climate itself continues evolving almost imperceptibly. Orbital variations gradually alter the distribution of sunlight, reaching different parts of the Earth across thousands of years. These changes influence monsoon systems, seasonal temperatures, and patterns of evaporation. Oceans absorb and release enormous quantities of heat. Vegetation expands and contracts in response, further affecting regional rainfall. None of these processes announces itself dramatically. Instead, they accumulate slowly, their consequences becoming visible only across many human lifetimes. Modern researchers reconstruct this hidden history using evidence unavailable to the ancient world. Deep within Greenland and Antarctic ice-trapped bubbles, preserve samples of ancient atmospheres. Lake sediments accumulate year after year like pages in a natural archive. Cave formations grow one thin mineral layer at a time, recording changes in rainfall chemistry. Fossil pollen reveals shifting plant communities. Together, these records show that even during the comparatively stable Holocene-important climatic transitions continue unfolding beneath the surface of ordinary human experience. The first societies thrive because they occupy a remarkably favourable chapter in Earth's environmental history. Yet favourable chapters do not last forever. The confidence that encourages villages to become towns and towns to become the earliest cities also blinds their inhabitants to a difficult truth. Stability is never permanent. It is only the temporary balance between forces far larger than any civilization can command. Across fertile valleys from North Africa to Southwest Asia, from Europe to Eastern Asia, the seasons still appear dependable. Rivers still nourish fields. Harvest festivals still celebrate abundance. But somewhere beyond the horizon of daily life, the first subtle disruptions are already beginning. The climate that has quietly supported humanity's greatest experiment is preparing to test whether those new societies can survive a world that no longer behaves as expected. The first societies are not built upon stone, they're built upon water. Walls of mud, brick, timber, and stone certainly define the outlines of villages, but beneath every foundation lies a quieter structure that determines whether people remain or leave. Rivers carry fertile silt across floodplains. Seasonal rains soften dry ground just long enough for seeds to germinate. Snowmelt from distant mountains feeds streams that farmers may never see at their source. Lakes moderate local temperatures and provide fish even when harvests disappoint. Marshes shelter birds, reeds, and countless small creatures that supplement human diets. Long before engineers shape canals or reservoirs, nature itself becomes the greatest architect of civilization. This relationship between water and settlement appears with remarkable consistency across the ancient world. Some of humanity's earliest permanent communities emerge beside rivers whose annual rhythms seem almost dependable enough to function as calendars. The Euphrates and Tigris spread nutrient-rich sediments across Mesopotamia. The Nile carries water northward through otherwise arid landscapes. Seasonal rivers nourish the Indus Valley. The Yellow River and Yangtze support growing populations in China. Even smaller waterways, many now forgotten or entirely vanished, sustain hundreds of communities whose names have disappeared from history. Water provides much more than drinking supplies. When rivers flood naturally, they replenish exhausted soils with fresh layers of mineral-rich sediment. Crops planted after the water's retreat often grow with remarkable productivity. Wetlands surrounding these floodplains become reservoirs of biodiversity. Fish spawn in shallow channels. Waterfowl gather in enormous numbers. Reeds provide material for roofs, baskets, mats, and boats. Clay deposited by floods becomes pottery bricks and storage vessels. Every seasonal rise in water quietly renews the resources upon which settled life depends. This abundance allows something previously impossible concentration. Instead of small bands scattered across enormous territories, hundreds and eventually thousands of people begin living within relatively compact settlements. Larger populations make cooperation easier. They also require increasingly sophisticated organization. Irrigation ditches must be maintained collectively. Fields require careful allocation. Water rights become matters of survival rather than convenience. Shared labor transforms landscapes that no individual family could reshape alone. One of the least appreciated achievements of these early societies is their extraordinary understanding of local hydrology. Without modern instruments, they learn where floodwaters linger longest, where groundwater remains accessible during dry seasons, and which channels naturally refill after heavy rains. Observation replaces technology. Experience accumulated across generations becomes an invaluable form of environmental knowledge. Archaeologists continue uncovering evidence of irrigation systems that demonstrate remarkable engineering skill. Some canals stretch for kilometers, carrying river water across gently sloping plains with gradients precise enough to maintain steady flow. Small embankments divert seasonal floods into agricultural fields before returning excess water to natural channels. Reservoirs capture rainfall for later use. Wells tap underground aquifers that recharge during wetter years. These systems are not signs that ancient people conquer nature. They reveal something subtler. Early farmers understand that survival depends upon working with existing environmental rhythms rather than attempting to overpower them. Successful irrigation complements natural flooding instead of replacing it. Crops are selected according to local conditions rather than imposed regardless of climate. Livestock graze lands unsuitable for cultivation, while contributing manure that enriches fields. The landscape and its inhabitants gradually become intertwined through thousands of practical decisions. The result is astonishing productivity. Settlements that once support only dozens of people now sustain hundreds. Some grow into towns with workshops, marketplaces, ceremonial spaces, and increasingly specialized occupations. Potters no longer need to spend much of their time gathering food because nearby farmers produce enough surplus grain to support them. Metalworkers experiment with copper and later bronze. Traders carry goods between distant communities. Administrators emerge to coordinate labor, distribute resources, and resolve disputes. Civilization begins taking recognizable form. Yet prosperity creates expectations. Children born into these growing settlements assume rivers will continue flooding. They expect wells to remain productive. They inherit agricultural calendars developed through generations of reliable observation. Houses are built not for temporary occupation, but for descendants who have not yet been born. Orchards require years before producing fruit, yet families plant them anyway, because they believe the future will resemble the past. This confidence encourages increasingly ambitious projects. In parts of Mesopotamia, irrigation networks expand farther from riverbanks, bringing cultivation into previously dry lands. Along the Nile, communities organize around annual inundations so regular that they shape religious ceremonies and administrative planning. In the Indus Valley, carefully planned settlements incorporate sophisticated drainage systems, suggesting remarkable attention to water management not only for agriculture, but also for urban sanitation. Although these civilizations differ greatly in language, culture, and political organization, each relies upon environmental predictability. What survives in the archaeological record suggests that water management often becomes a source of political authority. Leaders capable of organizing irrigation projects earn influence. Communities maintaining canals effectively enjoy larger harvests than their neighbours. Cooperation around shared water resources strengthens social cohesion, but it also creates dependence upon centralised coordination. The larger the settlement grows, the more difficult it becomes for individual households to solve problems independently. This growing complexity is both civilization's greatest strength and one of its hidden vulnerabilities. A small farming village can often adapt quickly when conditions change. Families alter planting schedules or temporarily relocate livestock. Large urban centres, however, require enormous quantities of food, delivered with remarkable consistency. Thousands of people who no longer grow their own grain depend upon intricate systems of transport, storage, and administration. A disruption affecting rainfall hundreds of kilometres away may eventually influence markets, workshops, and households far downstream. Few people living within these societies perceive how interconnected everything has become. To them, each successful harvest confirms that the system works. Granaries remain full, trade caravans continue arriving, children learn the same farming techniques their parents inherited. Festivals celebrate rivers that appear eternal. Temples and public buildings grow larger because prosperity inspires confidence rather than caution. Meanwhile, nature continues changing at its own pace. The evidence preserved in ancient lake beds reveals that rainfall begins fluctuating more noticeably in some regions. Shorelines retreat by small but measurable distances. Pollen records indicate gradual shifts from moisture-loving trees toward grasses better adapted to drier conditions. Dust transported by wind becomes more common in certain sediment layers. These are not yet signs of catastrophe. Instead, they resemble quiet warnings that ecosystems are beginning to adjust. No farmer living through a single lifetime would likely recognize the full significance of these changes. A slightly shorter flood season may simply seem unusual. One disappointing harvest can be blamed on insect or local weather. A dry decade remains within living memory as an unfortunate period rather than evidence of long-term transformation. Human experience naturally emphasizes immediate events. Climate, however, often communicates through slow accumulation. Scholars still debate exactly how early these warning signs become visible across different parts of the ancient world. Some regions experience gradual drying, while neighbouring landscapes remain productive for centuries longer. Others face alternating wet and dry periods rather than a steady decline. No single pattern explains every society. This complexity reminds researchers that environmental history rarely follows simple narratives. Even so, a broader picture continues emerging. The earliest civilizations flourished during one of the most environmentally favorable intervals in recent geological history. Their remarkable achievements in farming, engineering, architecture, and social organization are real and deserve admiration. But those achievements are always rooted in ecological conditions that remain beyond human control. The rivers still flow. The canals still carry water into green fields. Children still play beside marshes alive with birdsong. Merchants continue crossing fertile valleys where crops ripple beneath warm winds. Yet beneath this familiar landscape, invisible shifts are gathering strength. The balance between rainfall and evaporation, river and desert abundance and scarcity is beginning to tilt. The societies built upon water do not yet realize that the very element which created their world will soon become its greatest uncertainty. The change does not arrive as a single disaster. There is no morning when every river suddenly runs dry. No generation wakes to find fertile plains transformed overnight into desert. Instead, the climate begins to alter itself with extraordinary patience. It shifts so slowly that children often accept conditions their grandparents would have considered unusual. By the time entire societies recognize what is happening, the transformation has already been unfolding for centuries. One of the greatest misconceptions about ancient climate change is the expectation of sudden catastrophe. While volcanic eruptions and meteorite impacts can indeed produce abrupt environmental shocks, the changes that challenge many of the world's earliest societies often unfold through countless small adjustments in rainfall temperature and seasonal timing. Each adjustment seems manageable. Together they quietly redraw the map of human possibility. The story begins far above the villages themselves. The atmosphere circulates immense quantities of heat and moisture around the globe. Warm tropical air rises toward higher latitudes before cooling and descending. Oceans absorb sunlight during one season and gradually release that stored energy during another. Winds shift according to pressure differences stretching across continents. Monsoon systems, among the most powerful seasonal weather engines on Earth, carry enormous volumes of moisture inland before retreating once again toward the sea. These systems are never fixed. Even subtle changes in Earth's orbit around the Sun influence how much solar energy reaches different latitudes during different seasons. The planet's orbit is not perfectly circular. Its axial tilt slowly changes over thousands of years. The direction in which that tilted axis points also gradually shifts. These astronomical cycles unfold far too slowly for any individual to perceive, yet they steadily alter the intensity of summer heating and winter cooling across entire hemispheres. The consequences ripple through the climate. As northern summers become slightly less intense over thousands of years, monsoon circulation weakens in parts of Africa and Asia. Less solar heating means slightly weaker temperature contrasts between land and ocean. Those weakened contrasts reduce the strength of seasonal winds carrying moisture inland. Rain still falls, but perhaps not quite as far from the coast. Wet seasons arrive, but they may become shorter or less dependable than before. No farmer notices the orbital mechanics responsible for these changes. What they notice instead is practical reality. Perhaps fields nearest the river continue producing healthy harvests, while more distant plots become less reliable. Wells require deeper digging. Seasonal ponds disappear earlier each summer. Grazing animals travel farther before finding fresh vegetation. Hunters begin returning with fewer large animals because shrinking wetlands no longer attract the same abundance of wildlife. These observations rarely inspire panic. Human beings are remarkably adaptable. A single difficult year encourages adjustments rather than abandonment. Farmers plant slightly earlier or later depending upon recent weather. Families store additional grain after good harvests in preparation for uncertain seasons. Livestock herds change composition as goats capable of surviving on tougher vegetation gradually become more valuable than animals requiring lush pasture. These adaptations often succeed. Indeed, archaeological evidence suggests that many early communities respond creatively to environmental stress for generations before conditions become truly severe. They deepen irrigation canals, expand reservoirs, cultivate more drought-resistant crop varieties, and strengthen trade with neighboring settlements. Such innovations demonstrate that ancient societies are dynamic rather than helpless. Environmental pressure frequently stimulates remarkable ingenuity, yet adaptation also has costs. Constructing longer canals demands additional labor every year to prevent silting. Deeper wells require greater effort to maintain. Larger reservoirs lose more water through evaporation under hotter conditions. Fields pushed farther from reliable water sources become increasingly vulnerable during dry years. Every successful adaptation gradually ties society to infrastructure requiring constant maintenance. Complexity becomes both solution and burden. Across northern Africa, one of the most dramatic long-term transformations quietly unfolds. Thousands of years earlier, much of what is now the Sahara is astonishingly different from the vast desert familiar today. grasslands stretch across regions that currently receive almost no rainfall. Lakes dot the landscape. Rivers flow through valleys that are now dry. Crocodiles inhabit waters where only sand remains. Hippos wallow in freshwater pools. Herds of cattle graze broad savannas alongside antelope, giraffes, elephants, and countless other animals. People flourish there as well. Rock art preserved across the central Sahara depicts scenes almost unimaginable against the modern landscape. Cattle are herded through green pastures. Hunters pursue large game across open grasslands. Boats travel across substantial lakes. Communities occupy environments capable of supporting life on a scale difficult to envision today. Then the rains begin retreating. The African humid period lasting several thousand years after the Ice Age gradually comes to an end. As monsoon systems weaken, rainfall decreases across much of North Africa. Lakes begin shrinking. Rivers become seasonal rather than permanent. Grasslands slowly yield to expanding desert vegetation. Dust carried by strengthening winds increases across the region. This transformation does not occur everywhere simultaneously. Some valleys retain water long after surrounding landscapes dry. Highlands continue receiving rainfall unavailable to lower elevations. Large lakes shrink unevenly, leaving fertile shorelines that attract increasingly concentrated populations. Migration occurs in waves rather than mass exodus. Communities relocate toward remaining water sources while attempting to preserve familiar ways of life. What survives in the archaeological record reveals countless small decisions rather than one overwhelming catastrophe. Villages shift closer to dependable springs. Herding becomes more important where farming grows difficult. Hunting declines as wildlife populations contract alongside disappearing wetlands. Trade routes adjust to changing geography. New settlements appear where rivers remain reliable while others are quietly abandoned. The evidence remains incomplete because much of this history lies buried beneath modern deserts. Windblown sand conceals ancient campsites, dried lake beds, and forgotten pathways. Satellite imagery continues revealing traces of rivers that vanished thousands of years ago, allowing archaeologists to reconstruct landscapes almost entirely erased from the surface. Elsewhere, similar stories unfold under different conditions. In parts of Southwest Asia, rainfall patterns fluctuate enough to challenge dry farming in marginal regions. Communities occupying the edges of fertile zones experience increasing uncertainty. Areas that once supported dependable harvests begin requiring irrigation. Settlements dependent upon seasonal rainfall face greater risk than those situated beside perennial rivers. Even rivers themselves prove less predictable than earlier generations assumed. Snowfall in distant mountains influences downstream water supplies. Changing temperatures alter the timing of snowmelt. Reduced rainfall across vast watersheds eventually affects flood intensity hundreds of kilometers away. Farmers observing lower river levels may never know that the true cause lies in distant highlands beyond their horizon. Scholars still debate the precise timing and severity of these regional climate shifts. Some archaeological records indicate gradual drying extending across many centuries. Others reveal alternating wet and dry intervals interrupting longer trends. No single explanation fully accounts for every community's experience, because local geography shapes how climate change is felt. A valley protected by nearby mountains may remain productive long after surrounding plains deteriorate. Deep groundwater reserves sustain one settlement, while another only a short distance away struggles through repeated droughts. Human ingenuity, political organization, and access to trade further influence whether environmental stress leads to resilience or decline. Yet one pattern grows increasingly difficult to ignore. The favorable climatic window that nurtures humanity's first great agricultural expansion is beginning to narrow. The dependable world inherited from the earliest farmers slowly gives way to one demanding greater adaptation every generation. Most people living through these centuries never realize they are participating in one of history's greatest environmental transitions. They simply notice that each season asks a little more of them than the last. Fields require greater effort. Water becomes slightly harder to find. Harvests become marginally less certain. Small compromises accumulate into permanent adjustments. Entire landscapes gradually lose the abundance that once seemed natural. The drying has begun not as an event, but as a process patient enough to escape immediate notice, and powerful enough to reshape the destiny of civilizations, yet to reach their greatest heights. Long after the rivers change course and the fields fall silent, the earth continues keeping records. Unlike written history, these records never intend to tell a story. They are created one grain of dust, one drop of water, one season of growth at a time. A lake quietly collects sediment on its floor. A tree adds another ring beneath its bark. Mineral-rich water drips through the ceiling of a limestone cave, leaving behind an almost invisible layer of calcite. Wind carries pollen across valleys where it settles into mud. Year after year, century after century, nature assembles an archive so detailed that modern scientists can reconstruct climates from thousands of years ago with astonishing accuracy. The people who lived through these ancient transformations never knew they were writing this environmental diary. Every storm contributed another page. Every drought left another sentence. Every flood added another chapter. For much of archaeology's history, researchers focused primarily on the remains of human activity. Temples, pottery houses, tools and burials dominated excavation sites because these objects seemed to offer the clearest windows into ancient civilizations. Environmental evidence often received far less attention. A layer of mud was simply removed to expose walls beneath it. Dust was brushed aside. Tiny fragments of pollen or microscopic shells were rarely preserved because their significance had not yet been recognized. That approach has changed dramatically over the past few decades. Today, some of the most important discoveries about the earliest societies come not from spectacular monuments, but from evidence so small that it must be examined under a microscope. Entire research teams specialize in reconstructing vanished environments from clues invisible to the naked eye. Their work has transformed our understanding of how climate shapes human history. One of the richest archives lies beneath ancient lakes. Every year, particles carried by rivers, rainfall, and wind settle gently onto lake bottoms. Organic matter from plants mixes with tiny minerals washed in from surrounding hills. During wetter years, deeper water protects these layers from disturbance. During prolonged droughts, falling lake levels expose sediments to erosion or increase the concentration of minerals left behind as water evaporates. When scientists extract long cores from these lake beds, they recover something resembling a timeline buried beneath the mud. The deepest layers represent the oldest environments. Each successive layer records another period in the lake's history. By analyzing pollen trapped within the sediments, researchers identify which plants dominate the surrounding landscape at different times. Large quantities of oak or pine pollen suggest forests. Increasing grass pollen may indicate expanding open country. Rising concentrations of desert shrubs reveal drying conditions. The changing proportions of these microscopic grains reveal landscapes transforming over centuries. Perhaps most remarkably, pollen survives extraordinarily well. Although the plants themselves disappear long ago, their pollen grains remain sealed within oxygen-poor mud, preserving evidence of ecosystems that no longer exist. Through these tiny fossils, forests lost thousands of years earlier briefly return to scientific view. Lakes preserve other secrets as well. The remains of microscopic algae change according to water chemistry. Certain species flourish in fresh water. Others tolerate increasing salinity. As lakes shrink under prolonged drought, evaporation concentrates dissolved minerals, altering which organisms survive. These subtle biological shifts provide independent confirmation that rainfall is changing. No single piece of evidence stands alone. Researchers compare pollen with algae sediment, grain size, mineral composition, and radiocarbon dating to build increasingly reliable reconstructions. When several independent indicators point toward the same conclusion, confidence grows that genuine climatic change has occurred rather than isolated local variation. Caves offer another remarkable archive. Deep inside limestone caverns, rainwater slowly filters through rock before dripping from ceilings. Each drop carries dissolved calcium carbonate. Over thousands of years, these deposits accumulate into stalagmites rising from cave floors and stalactites hanging above them. Their slow growth creates visible bands much like tree rings, yet these mineral formations preserve far more than age alone. The chemical composition of each layer reflects the rainfall that produced it. Different isotopes of oxygen become more or less common depending upon temperature, precipitation, and evaporation. By carefully analyzing these variations, scientists reconstruct changing rainfall patterns with extraordinary precision. Some stalagmites reveal centuries of relatively stable conditions followed by gradual drying. Others record abrupt wet periods interrupting longer droughts. Together they demonstrate that ancient climates are neither perfectly stable nor uniformly unpredictable. Instead, they fluctuate within patterns that vary across regions. What survives in cave records often matches evidence found elsewhere, strengthening the overall picture. Tree rings provide another invaluable source of information. In regions where ancient wood survives, each annual growth ring reflects environmental conditions during a particular year. Wet seasons generally produce wider rings because trees grow more vigorously. Dry years leave narrower bands. Long sequences from living trees combined with preserved ancient timber allow researchers to reconstruct rainfall extending back thousands of years. Unlike lake sediments, tree rings frequently offer annual resolution. Instead of estimating conditions across centuries, scientists sometimes identify individual years of severe drought. This level of detail reveals that ancient societies often experience clusters of difficult seasons rather than uninterrupted decline. A few favorable years may temporarily relieve environmental stress before dry conditions return. The climate story becomes increasingly complex. Coastal sediments preserve evidence from the oceans. As rivers carry soil toward the sea, they deposit sediments containing pollen minerals and microscopic marine organisms. Ocean currents influence which species dominate particular regions. Changes in sea surface temperatures alter biological communities whose remains accumulate on the seabed. Deep-sea drilling projects recover sediment cores extending back hundreds of thousands, even millions of years. These marine archives demonstrate how interconnected Earth's climate systems truly are. A weakening monsoon over Africa may influence dust transported across the Atlantic Ocean. Changing temperatures in the North Atlantic affect rainfall reaching Europe and parts of Southwest Asia. Ocean circulation redistributes heat on scales far exceeding individual continents. Ancient farmers observe only local weather. Modern science reveals planetary connections. Satellite technology has added yet another dimension to this investigation. From hundreds of kilometers above Earth, satellites detect buried river channels hidden beneath desert sands. Subtle differences in soil moisture reveal forgotten irrigation systems. Radar penetrates dry sand to expose landscapes concealed for thousands of years. Across the Sahara, satellite imagery has uncovered enormous fossil rivers that once carried substantial flows through regions now receiving almost no rainfall. These discoveries help explain why archaeological sites appear in places that initially seem incapable of supporting large populations. The evidence remains incomplete because countless records have been destroyed. Ancient lakes dry completely before preserving continuous sediment sequences. Erosion removes crucial layers. Human agriculture disturbs older deposits. Some caves cease forming mineral records when local hydrology changes. Tropical climates rapidly decompose wood that might otherwise preserve tree ring histories. Scientists therefore rely upon overlapping evidence. One archive fills gaps left by another. Lake sediments complement cave formations. Tree rings reinforce pollen records. Marine cores confirm continental changes. Archaeological excavations provide the human response alongside the environmental signal. No single explanation fully accounts for every detail, but together these independent sources converge upon an increasingly compelling narrative. The climate supporting the world's earliest agricultural societies gradually becomes less reliable across many regions. Rainfall shifts, wetlands contract, vegetation changes, rivers behave differently. These transformations unfold over generations rather than days, making them nearly impossible for any individual to recognize in their entirety. Ironically, modern researchers often understand these long-term changes more clearly than the people who actually live through them. Standing in an excavation trench today, an archaeologist may hold a handful of ancient pollen or examine a thin slice of cave mineral no thicker than a fingernail. To the casual observer, these fragments seem insignificant. Yet within them survives one of history's greatest witnesses. The Earth itself remembers what the first civilizations could not fully see. It remembers every season when the rains arrived late. It remembers every century when lakes slowly retreated. And it remembers the quiet beginning of the environmental transformation that would soon place the earliest societies under pressures unlike anything their founders had ever imagined. The first failed harvest is rarely remembered as the beginning of collapse. Instead, it becomes one difficult year among many successful ones. Farmers blame unusual weather insects, poor timing, or simple bad fortune. Grain stores still contain enough food from previous seasons. Livestock continue grazing. Markets remain open. Children laugh in village streets. Nothing yet suggests that the foundations of society are beginning to weaken. This is how environmental crises often unfold. They begin beneath the threshold of alarm. For generations, early agricultural communities learn to expect occasional setbacks. Floods sometimes arrive too early. Frost occasionally damages young shoots. Storms flatten fields just before harvest. Such events are frustrating, but they are familiar. Human beings have always lived with uncertainty, and the earliest farmers are no exception. The danger emerges when unusual seasons stop being unusual. Imagine a farming family living near the edge of a fertile plain. Their grandparents remember fields that remained green well into late summer. Springs once flowed throughout the year. The nearby stream watered small gardens, even after the main harvest had ended. Those memories become increasingly difficult for younger generations to recognize. They inherit a landscape that has already changed slightly, though not enough to abandon entirely. Each generation adjusts its expectations. The stream now dries by midsummer rather than early autumn. Farmers begin planting earlier in hopes of capturing spring moisture. Livestock are driven farther from the village to find pasture. Wells are dug a little deeper every decade. None of these changes appears dramatic in isolation. Together, however, they reveal an environment slowly becoming less generous. The consequences spread unevenly through society. Families occupying the richest land closest to dependable rivers often continue producing adequate harvests. Those farming marginal soils suffer first. Crops growing on shallow hillsides fail more frequently than those rooted in fertile floodplains. Communities dependent upon seasonal rainfall face greater risks than settlements supplied by permanent rivers. What survives in the archaeological record suggests that inequality may quietly increase during these periods of environmental stress. Wealthier households possess larger grain reserves. They own more livestock capable of surviving temporary shortages. They maintain broader trade connections through which food can be acquired from less affected regions. Poorer families enjoy far fewer options. One failed harvest may force them to consume seed grain intended for the following planting season. Another disappointing year leaves little room for recovery. Food shortages rarely produce immediate famine. Instead, diets begin changing. Animal bones recovered from ancient settlements reveal shifting patterns of consumption. Communities may slaughter younger livestock because maintaining large herds becomes increasingly difficult. Wild plants once considered occasional supplements grow more important. Fish disappear from diets where shrinking wetlands reduce available habitat. Hunting expands into areas previously visited less frequently. These adaptations reflect resilience rather than desperation. Ancient societies are remarkably inventive when faced with hardship. Farmers experiment with crops requiring less water. Barley often replaces thirstier cereals because it tolerates drier conditions. Goats become increasingly valuable in regions where cattle struggle to find sufficient pasture. Storage facilities grow larger in an effort to preserve food through uncertain seasons. Innovation slows decline but cannot eliminate environmental limits. As harvests become less reliable, every surplus becomes precious. Grain that might once have been traded or consumed during festivals is instead carefully stored against the possibility of another poor year. Communities become more cautious. Riskier agricultural experiments decline. Families devote increasing effort simply to maintaining previous levels of production. The psychological consequences are impossible to measure directly, yet archaeology offers intriguing hints. Some settlements invest more heavily in communal storage structures, suggesting greater concern for food security. Others strengthen defensive walls, perhaps reflecting rising competition over increasingly scarce resources. Religious sites sometimes expand during periods of environmental uncertainty, although scholars still debate exactly what these changes represent. Ritual activity may intensify as communities seek reassurance in traditions connecting them to the natural cycles upon which survival depends. The evidence remains incomplete, but the pattern appears repeatedly enough to invite careful consideration. Water becomes the defining concern. Irrigation canals that once function almost effortlessly require constant maintenance. Lower river levels allow sediment to accumulate more rapidly within channels. Workers must remove silt year after year simply to preserve existing water flow. Wells reach deeper into declining groundwater reserves. Reservoirs lose increasing amounts of stored water through evaporation during hotter summers. Labor demands increase precisely when agricultural productivity begins declining. This creates one of civilization's most dangerous feedback loops. More people are required to maintain irrigation infrastructure, leaving fewer available for farming. Reduced harvests provide less food to support those laborers. Every additional canal, reservoir, or embankment solves one problem while creating new obligations extending far into the future. Communities become trapped by the very systems that once ensured their prosperity. Archaeologists studying ancient fields occasionally discover abandoned irrigation networks stretching across landscapes now too dry for cultivation. These canals represent enormous investments of human effort. Thousands of workers spend years constructing them. Entire political systems organize labor around their maintenance. Their eventual abandonment suggests not carelessness, but overwhelming environmental pressure. Salt introduces another hidden threat. In many irrigated regions, particularly where evaporation exceeds rainfall, dissolved minerals accumulate gradually within agricultural soils. Each application of irrigation water leaves behind tiny amounts of salt after moisture evaporates. Over centuries, these deposits build until crop yields begin declining. Ancient farmers recognized the symptoms long before understanding the chemistry. Fields once producing abundant grain become increasingly unproductive. White mineral crusts occasionally appear on the soil surface. Sensitive crops fail first. More salt-tolerant plants gradually replace them. Mesopotamian agricultural records preserved from later periods indicate growing reliance on barley, a crop capable of surviving higher soil salinity than wheat. Scholars continue debating exactly how significant salinization becomes in different regions, yet it clearly compounds existing environmental challenges. The climate is not solely responsible. Human decisions amplify natural pressures. Expanding cultivation into marginal lands increases vulnerability during drought. Overgrazing reduces vegetation, protecting soils from erosion. Extensive irrigation without adequate drainage accelerates salt accumulation. Population growth demands ever greater agricultural output from landscapes whose productivity is already beginning to decline. No single explanation fully accounts for the difficulties facing early societies. Climate creates pressure. Human choices influence resilience. Together they determine outcomes. Elsewhere, similar patterns emerge under different circumstances. Across regions formerly rich in wetlands, shrinking lakes reduce fish populations that once buffered communities against poor harvests. Grasslands supporting wild herbivores contract making hunting less reliable. Forests retreat, limiting supplies of timber and fuel. Every ecological change echoes through human economies in ways both obvious and subtle. Trade initially softens these impacts. Communities experiencing local shortages import grain from neighboring regions, enjoying better conditions. Exchange networks redistribute resources across considerable distances. Merchants become increasingly important because they connect areas affected differently by changing climate. Yet trade possesses limits. When environmental stress expands across multiple regions, simultaneously fewer surplus supplies remain available for export. Prices likely rise, although direct evidence is difficult to reconstruct. Competition for remaining resources intensifies. Political tensions become harder to separate from ecological pressures. What survives in the record suggests that many ancient societies endured decades, even centuries of mounting difficulty before reaching irreversible decline. This gradual process is perhaps the most sobering lesson preserved by archaeology. Civilizations do not usually vanish because one harvest fails. They weaken because each disappointing season leaves them with slightly fewer reserves, slightly less flexibility, and slightly greater dependence upon environmental conditions that continue becoming less predictable. The fields still produce grain. The rivers still carry water. Children are still born beneath familiar skies. Yet beneath this appearance of continuity, the margin between abundance and scarcity grows thinner every generation. The first societies have entered an age where survival depends not upon avoiding hardship altogether, but upon enduring a sequence of challenges that arrive slowly enough to feel almost ordinary until ordinary life itself begins to disappear. Long before abandoned cities appear in the archaeological record, the roads begin filling with people, not with conquering armies or organized expeditions, but with families carrying what they can no longer leave behind. A few bundles of grain, clay vessels wrapped in woven cloth, children walking beside goats too valuable to abandon, elderly relatives moving more slowly than the rest. Dogs circling the edges of the group, uncertain why familiar paths no longer lead home. Migration rarely announces itself as history in the making. To those living through it, migration is simply the next practical decision after every other solution has failed. One well dries beyond recovery. A harvest fails for the third consecutive year. The grazing land that once supported an entire herd now feeds only a handful of animals. Neighbors quietly disappear during the winter, leaving behind empty houses whose doors swing in the wind. Eventually another family decides to follow. Modern maps often present ancient civilizations as clearly defined territories separated by borders, but the reality is far more fluid. The earlier societies exist within landscapes constantly shaped by movement. Traders travel between settlements carrying stone shells, metals, and grain. Shepherds move seasonally with their flocks. Hunters follow migrating animals. Pilgrims visit sacred places. Marriage connects distant communities. Climate change does not create mobility. It transforms its scale and purpose. Instead of temporary journeys followed by return, movement increasingly becomes permanent. The archaeological record captures this transition in subtle ways. Some settlements gradually shrink rather than ending in sudden destruction. Houses are abandoned one at a time. Storage pits remain partially filled. Workshops cease operating. Public buildings receive fewer repairs. There is little evidence of violent catastrophe because people leave deliberately rather than under immediate attack. Silence replaces activity. Wind begins carrying dust across courtyards where grain was once dried in the sun. Birds nest in roof beams no longer maintained. Irrigation channels slowly clog with sediment because no one clears them each spring. Over decades, entire communities fade into the landscape without dramatic endings. Elsewhere, other settlements begin growing. Villages located beside dependable springs suddenly expand. River valleys receiving more consistent water attract newcomers from increasingly arid uplands. Archaeologists identify these changes through rising numbers of houses, expanding cemeteries, and growing quantities of pottery and tools. Population does not disappear. It moves. This distinction is essential. For much of the 19th and early 20th centuries, abandoned settlements were often interpreted as evidence that entire peoples had vanished. Modern archaeology paints a more complicated picture. Many ancient communities survive environmental change not by remaining where they are, but by relocating to landscapes better able to sustain them. The movement itself, however, is rarely easy. Families leaving established villages abandon more than buildings. They leave orchards planted by previous generations, irrigation canals maintained through years of labour burial grounds, where ancestors rest, and sacred places woven into community identity. Every departure represents the loss of accumulated history as much as accumulated property. The emotional cost remains invisible in archaeological evidence, yet it must have been profound. Imagine spending an entire lifetime building terraces into a hillside, planting fruit trees that require decades to mature, constructing stone walls by hand, only to realize that diminishing rainfall makes continued survival impossible. Walking away from such investments is not a simple economic calculation. It is an acknowledgement that the landscape itself has changed beyond recognition. One of the clearest examples of climate-driven migration emerges from the drying Sahara. Thousands of years earlier, people occupy broad grasslands scattered with lakes and rivers. Rock paintings depict thriving communities raising cattle and hunting abundant wildlife. As rainfall gradually declines, these populations do not vanish. Instead, they begin moving. Many migrate toward the Nile Valley, where dependable river water continues supporting agriculture, even as surrounding regions become increasingly arid. Others settle around shrinking lakes that temporarily preserve productive ecosystems. Some adapt by emphasizing pastoralism, moving livestock between scattered grazing areas instead of relying upon permanent farming. Scholars still debate the precise routes followed by these ancient migrations, but genetic studies, archaeological discoveries, and environmental evidence increasingly suggest that the gradual desertification of North Africa reshapes population patterns across enormous distances. The consequences extend far beyond the Sahara itself. Growing populations along reliable rivers place greater pressure upon limited resources. Agricultural land becomes more valuable. Existing settlements expand. Cultural traditions from different regions meet, mix, and evolve together. New technologies spread alongside migrating families. Migration becomes a powerful engine of cultural change. The same pattern appears elsewhere. In Southwest Asia, communities occupying marginal farming regions gradually relocate toward more dependable water sources. Some settlements disappear entirely while nearby river valleys experience increasing occupation. Trade routes adjust to connect emerging centers of population rather than abandoned ones. The archaeological evidence rarely suggests chaotic flight. Instead, migration unfolds over generations. Grandparents may remember the old village. Parents divide their time between two settlements. Children grow up considering the new community home. History often compresses these slow transformations into single events, but reality is measured in lifetimes. Climate also alters the movement of animals. Wild herds shift their migration routes as vegetation changes. Fish populations decline in shrinking lakes. Birds abandon wetlands that no longer provide sufficient water. Human communities dependent upon these animals must either follow them or develop entirely new ways of securing food. This ecological domino effect reaches surprisingly far. Pastoral societies moving livestock into unfamiliar territories encounter neighboring communities already occupying those grazing lands. Competition over waterholes intensifies. Seasonal agreements that functioned well during wetter centuries become increasingly difficult to maintain. Conflict becomes more likely, yet scholars caution against reducing ancient violence to simple climate explanations. The evidence remains incomplete, and no single explanation fully accounts for episodes of warfare or social tension. Environmental pressure often creates conditions in which existing political rivalries become more dangerous, but human choices still determine whether disputes end through negotiation, migration, trade, or armed conflict. Climate change's opportunities. People determine responses. This distinction matters. One of the more surprising discoveries emerging from recent archaeological research is that migration frequently spreads innovation rather than merely reflecting crisis. Families arriving in new regions bring agricultural knowledge adapted to difficult conditions. They introduce drought-resistant crops, improved irrigation techniques, and different methods of managing livestock. Pottery styles change. Burial customs evolve. Languages borrow unfamiliar words. Trade expands into previously disconnected areas. Movement reshapes civilization. Genetic evidence reinforces this picture. Ancient DNA recovered from human remains increasingly reveals that populations once assumed to be isolated are often connected through repeated episodes of migration. Communities exchange not only goods and ideas, but also families across remarkable distances. Climate-driven mobility contributes to the complex ancestry of later civilizations in ways only recently becoming visible through scientific research. The roads of the ancient world are therefore not merely routes of escape. They are pathways through which new societies emerge. Every abandoned village leaves behind descendants living elsewhere. Every drying valley contributes people to another landscape. Every difficult journey carries knowledge accumulated across generations. Still, not everyone leaves. Some communities remain behind, convinced that the rains will eventually return. Others possess too few resources to relocate. Elderly inhabitants may refuse to abandon ancestral homes. Religious traditions tied to particular places encourage perseverance despite worsening conditions. These settlements often endure far longer than modern observers might expect. Human beings possess an extraordinary capacity to hope that familiar patterns will reassert themselves. Sometimes they do. Sometimes a series of favorable years temporarily restores confidence. Fields become green again. Wells refill. Children once more assume the difficult years have passed. Yet beneath these brief recoveries, larger climatic trends continue unfolding. The migrations gathering across the ancient world are not isolated episodes, but early signals of a transformation still gaining momentum. Entire populations are beginning to redraw humanity's map one careful journey at a time, following water toward landscapes that still promise stability. while leaving behind silent settlements that future archaeologists will one day uncover beneath layers of dust and forgotten time. Some settlements survive the changing climate for centuries, others do not. From a distance, the earlier cities appear almost invincible. Thick defensive walls surround dense neighborhoods. Public buildings dominate the skyline. Granaries overflow after successful harvests. Workshops produce pottery textiles, metal tools and ornaments that travel hundreds of kilometers through expanding trade networks. Administrators record harvest, labor and taxes. Religious centers organize ceremonies marking the passage of the seasons. These places represent the greatest achievements of early civilization, yet their greatest strength conceals their greatest weakness. The larger a city becomes, the more completely it depends upon systems extending far beyond its walls. A village may survive on nearby fields alone. A growing city cannot. It requires grain from distant farms, livestock from surrounding pastures, timber from forests, stone from quarries, and water from rivers whose sources lie far beyond the horizon. Every additional resident increases dependence upon networks that must function with remarkable reliability. When the environment begins changing, these networks feel the strain long before city walls begin crumbling. Archaeologists often describe ancient urban centers as hubs within wider landscapes rather than isolated places. Their prosperity depends upon thousands of farmers working fields beyond the city's boundaries. Roads carry food inward while manufactured goods flow outward. Rivers transport heavy cargo more efficiently than wagons. Markets connect producers and consumers through relationships built over generations. Climate pressure weakens every link simultaneously. A slight decline in rainfall may reduce harvests in one district without causing immediate alarm. Another region experiences insect outbreaks after unusually warm seasons. A third loses grazing land as vegetation retreats. Individually, each problem seems manageable. Together, they reduce the overall surplus reaching the city. The change is subtle at first. Market stalls still display grain. Bread remains available. Workshops continue operating. Temples remain active. But administrators begin noticing that taxes collected in grain are smaller than expected. Storage facilities empty more quickly during winter. Merchants travel farther in search of reliable suppliers. Prices likely fluctuate, though the archaeological record preserves only indirect hints of such economic pressures. Urban life depends upon confidence. Citizens expect food to arrive because it always has. Craftsmen assume farmers will exchange grain for tools. Farmers trust that canals will continue delivering irrigation water. Political leaders believe labourers can be mobilised for public works because surplus harvests will sustain them. Environmental stress gradually erodes that confidence. One remarkable aspect of early cities is how carefully they attempt to manage uncertainty. Granaries become central institutions rather than simple storage buildings. During productive years, grain accumulates against future shortages. Administrative systems emerge partly to organize these reserves. Written records, where they exist, often devote considerable attention to harvest, taxation, and food distribution. This is not merely bureaucracy. It is an attempt to stabilize society against environmental unpredictability. Some cities succeed for surprisingly long periods. Improved irrigation expands cultivated land beyond natural floodplains. Reservoirs capture seasonal water. Trade compensates for local shortages by importing grain from less affected regions. Political authorities coordinate labor on a scale impossible for individual villages. These achievements deserve admiration. They demonstrate that civilization is capable of remarkable adaptation. Yet every solution introduces new complexity. Longer irrigation canals require larger maintenance crews. Greater food storage demands more administrators. Expanded trade depends upon secure transportation routes. Growing populations increase total food consumption. the city's resilience becomes inseparable from its organizational complexity. When multiple pressures arrive together, complexity itself becomes difficult to sustain. One particularly revealing pattern appears repeatedly in archaeological excavations. Public architecture often changes before ordinary housing does. Large ceremonial buildings may receive fewer repairs. Defensive walls show signs of neglected maintenance. Drainage systems become clogged. Streets accumulate debris that earlier generations carefully removed. These details suggest that collective labor, the ability of society to organize large public projects, begins weakening even while daily household life continues. The city still functions, it simply functions less efficiently than before. Meanwhile, families adapt privately. Households store more food whenever possible. Small gardens become increasingly valuable. Domestic animals are kept closer to homes. Pottery designed for long-term storage appears more frequently at some sites. These quiet adjustments rarely attract attention individually, yet together they reveal communities preparing for greater uncertainty. Scholars still debate exactly how much climate contributes to these urban transformations. The evidence remains incomplete because every city possesses its own history. Political instability may interrupt trade regardless of environmental conditions. Warfare destroys infrastructure even where rainfall remains adequate. Epidemic disease can reduce labor forces unexpectedly. Economic inequality leaves some populations vulnerable long before climate becomes a serious problem. No single explanation fully accounts for urban decline. Instead, climate often acts as what historians sometimes describe as a stress multiplier. A well-governed city with abundant reserves may survive decades of difficult weather. A politically divided society already struggling with inequality or conflict may find that the same environmental pressures become overwhelming. This interaction between natural and human systems appears especially important. Cities are not passive victims. Neither are they immune. Excavations across Southwest Asia reveal settlements that contract gradually rather than collapsing dramatically. Outer neighborhoods are abandoned while central districts remain occupied. Public buildings continue functioning long after residential areas shrink. Population decreases unevenly instead of disappearing altogether. Urban decline resembles a slow retreat more than a sudden fall. Some cities successfully reinvent themselves. Trade replaces agriculture as their primary source of prosperity. Others reduce their population while maintaining political importance. Certain settlements relocate slightly to better access water or more defensible terrain. Adaptation remains possible, but adaptation requires resources. Communities already exhausted by repeated poor harvests possess fewer options than those entering difficult periods from positions of strength. One lesser-known detail emerging from recent research concerns groundwater. Modern hydrological studies suggest that some ancient cities increasingly relied upon underground water reserves as rivers became less dependable. Wells deepened over successive generations. Springs that once flowed naturally required greater effort to access. Initially, groundwater buffered communities against declining rainfall. Eventually, however, these reserves also diminished where recharge failed to keep pace with extraction. The invisible water beneath the ground followed the same climatic trends affecting rivers above it. Urban sanitation presents another challenge. Growing cities require reliable water not only for drinking but also for waste removal. Sophisticated drainage systems found in places such as the Indus Valley demonstrate remarkable engineering. Yet these systems function best when adequate water remains available. Reduced flow complicates sanitation, potentially increasing health risks, even if direct evidence is difficult to recover archaeologically. Every urban problem becomes connected. Food shortages influence labor. Labor affects infrastructure. Infrastructure shapes water management. Water determines agriculture. Agriculture supports trade. Trade finances administration. Administration maintains stability. The city survives only while this interconnected web continues functioning. As climate slowly becomes less predictable, maintaining every connection demands increasing effort. To those living inside these cities, the transformation rarely feels like living through the collapse of civilization. It feels like solving one practical problem after another. Repair another canal, dig another well, import grain from farther away, expand another storage building, recruit more workers, raise another embankment, hope next year's rains return. Generation after generation, these practical responses postpone disaster. Yet postponement is not always prevention. Beyond the city walls, the surrounding countryside continues changing. Villages disappear from increasingly marginal lands. Pastures shrink. Rivers fluctuate more dramatically. Trade routes lengthen as nearby resources become scarcer. The cities still stand, their towers visible across the plain symbols of human achievement against the horizon. But the landscapes that sustain them are quietly slipping beyond the balance upon which every brick, every marketplace, every temple, and every household ultimately depends. The first urban civilizations are discovering that even the greatest cities cannot remain stronger than the environments that give them life. No two civilizations experience the changing climate in exactly the same way. The forces altering rainfall, river flow, and seasonal temperatures reach across continents, yet every landscape responds according to its own geography. A mountain range preserves snow that continues feeding rivers long after surrounding plains begin drying. A broad floodplain buffers years of weak rainfall more effectively than isolated valleys. Coastal regions receive moisture unavailable to inland settlements. Human decisions further complicate the picture. Some societies invest heavily in irrigation. Others depend almost entirely upon seasonal rains. Political organization, trade technology, and local ecology all influence whether environmental stress becomes a temporary hardship or a lasting crisis. For this reason, the great civilizations of the ancient world do not rise and struggle in unison. Each follows its own path. Mesopotamia occupies one of the most productive yet demanding environments on Earth. The Tigris and Euphrates rivers transform otherwise arid landscapes into fertile agricultural land. Unlike rivers fed primarily by local rainfall, these waterways depend upon snowmelt and precipitation, falling hundreds of kilometers away in the mountains of Anatolia and the Zagros. Farmers living on the southern plains therefore rely upon weather they never witness directly. This arrangement offers tremendous opportunity. It also introduces hidden uncertainty. When mountain snowfall decreases or meltwater arrives at unusual times, communities downstream experience consequences they cannot easily predict. Floods may come earlier or later than expected. Some years produce destructive inundations, while others leave irrigation canals struggling to reach distant fields. The people of Mesopotamia respond with extraordinary ingenuity. They construct extensive canal networks, build levees, regulate water distribution, and develop administrative systems capable of coordinating enormous labor forces. These achievements support some of humanity's earliest cities, including places whose populations far exceed anything previously imagined. Yet irrigation creates long-term challenges alongside immediate benefits. Repeated watering under hot, dry conditions gradually increases salt concentrations in many agricultural soils. Archaeological evidence and surviving administrative texts from later Mesopotamian societies suggest changing crop preferences over time, with barley becoming increasingly dominant because it tolerates higher salinity than wheat. Scholars continue debating exactly how severe this problem becomes in different periods, but it almost certainly interacts with broader climatic pressures rather than existing independently. The story unfolding farther east differs in important ways. The Indus Valley civilization develops across an enormous region stretching through parts of present-day Pakistan and northwestern India. Unlike many earlier urban societies, its major settlements display remarkable planning. Streets intersect at regular angles. Sophisticated drainage systems carry wastewater away from houses. Standardized bricks appear across vast distances, suggesting impressive organizational consistency. For many years, researchers struggled to explain why numerous Indus cities gradually declined. There is little evidence for widespread conquest. No overwhelming destruction layer marks the end of the civilization. Instead, archaeological evidence increasingly points toward gradual transformation. One leading explanation involves changing river systems combined with weakening monsoon patterns. Some rivers shift course naturally over time. Others receive less seasonal water as rainfall patterns evolve. Communities dependent upon these waterways adapt by relocating toward regions where water remains more reliable. The evidence remains incomplete because river behavior is extraordinarily complex. Geological processes, tectonic activity, sediment accumulation, and climate all influence changing channels. No single explanation fully accounts for every abandoned settlement. Even so, a broad pattern has emerged. Urban populations gradually disperse. Large cities shrink. Smaller rural settlements become more common. Rather than disappearing, many people reorganize into different forms of community better suited to changing environmental conditions. The Nile Valley presents another striking contrast. Ancient Egypt appears unusually resilient because the Nile functions as one of the world's most dependable rivers. Annual flooding, driven largely by rainfall in the Ethiopian highlands, deposits fertile silt across narrow floodplains bordered by desert. This regularity shapes nearly every aspect of Egyptian civilization. Agricultural calendars, taxation, religious ceremonies, and political authority all become closely connected to the river's predictable cycle. Yet even the Nile is not immune to climate. Historical and geological evidence indicates periods when flood levels decline significantly. Poor inundations reduce agricultural productivity, strain food supplies, and challenge political stability. Later Egyptian texts occasionally describe years of hardship associated with inadequate flooding, although interpreting these sources requires caution because literary and political motives sometimes influence their descriptions. Still, the larger pattern is clear. Even one of history's most stable river systems remains vulnerable to broader climatic variation. Farther west North Africa continues undergoing dramatic transformation. As the Sahara dries, populations increasingly concentrate along the Nile and other remaining reliable water sources. The desert becomes not simply an empty barrier, but a powerful force redirecting human movement across the continent. Ancient rock art scattered through today's barren landscapes preserves haunting reminders of this earlier world. Images of swimmers decorate cave walls now standing hundreds of kilometers from permanent water. Cattle graze across cliffs overlooking endless dunes. Hippos, giraffes, elephants, and crocodiles appear in places where survival today would be impossible. These paintings are not symbolic fantasies. They document environments that genuinely existed. Modern paleoclimate research confirms that the artists lived in landscapes transformed almost beyond recognition. Meanwhile, communities across the eastern Mediterranean experience their own environmental challenges. Some regions become increasingly dependent upon maritime trade as local, agricultural production fluctuates. Others diversify economies through craft production, mining, or exchange networks extending across the sea. Adaptation takes many forms. There is no universal response. One of the most fascinating aspects of these ancient civilizations is how differently they balance local resources against wider connections. Highly connected societies enjoy access to distant supplies during regional shortages. At the same time, they become vulnerable when disruption spread across multiple areas simultaneously. Isolation offers independence. Connectivity offers resilience. Both strategies carry risks. Recent climate reconstructions reveal that environmental changes are often asynchronous. A drought affecting Mesopotamia may not occur at exactly the same time as one influencing Egypt. Monsoon weakening may unfold gradually, while Mediterranean rainfall follows different patterns. This lack of perfect synchronization explains why trade sometimes softens environmental stress. Communities suffering poor harvests import food from regions experiencing more favorable conditions. Only when climatic disruptions become widespread do these safety networks begin failing. Scholars continue debating how closely specific episodes of societal change correspond with reconstructed climate events. The uncertainty is important. History rarely provides neat timelines where one drought immediately produces one political collapse. Instead, environmental pressure accumulates alongside economic tensions, demographic changes, technological developments, and shifting political relationships. Climate creates conditions. Human societies determine outcomes. This principle appears repeatedly across the ancient world. Some civilizations fragment, others reorganize, some migrate, others innovate. Many survive in altered forms rather than disappearing entirely. Perhaps the greatest lesson emerging from these comparisons is that resilience is never permanent. Every successful adaptation solves the problems of one generation, while creating new challenges for the next. Canals require maintenance. Reservoirs accumulate sediment. Trade depends upon political stability. Growing populations consume expanding resources. The achievements of civilization continuously increase dependence upon environmental balance. Across the great river valleys and fertile plains of the ancient world, people continue planting, harvesting, building, trading, and raising families. Their cities remain among humanity's greatest accomplishments. Yet beneath their success lies an increasingly fragile foundation. The same climate that once encouraged the birth of civilization is becoming less predictable with every passing century, forcing each society to confront a question that no monument, no king and no engineer can answer alone. How long can a civilization endure when the world that created it slowly begins to change? When archaeologists first began uncovering the ruins of ancient civilizations, the search for a single cause of collapse seemed almost irresistible. A burned palace suggested invasion. A toppled wall implied an earthquake. A deserted city invited stories of sudden catastrophe. Human history appeared easier to understand if every ending could be traced to one dramatic event. Entire civilizations were imagined falling in a matter of weeks, defeated by armies, consumed by floods, or shattered by disasters that left unmistakable scars across the landscape. The evidence accumulated over the last several decades tells a more complicated story. Again and again, researchers find that societies rarely collapse because of one isolated crisis. Instead, they weaken through the interaction of many different pressures, each amplifying the effects of the others. Climate change often plays an important role, but it almost never acts alone. Human choices, political institutions, economic systems, technological limitations, and social inequality all shape whether environmental stress becomes manageable hardship or irreversible decline. Understanding this distinction changes how the ancient world is viewed. Climate is not a villain arriving from outside civilization. It becomes one participant in a far larger chain of events. Imagine two neighboring kingdoms experiencing the same prolonged reduction in rainfall. Both harvest less grain than previous generations. Rivers flow at lower levels. Livestock struggle through longer dry seasons. Yet their outcomes differ dramatically. One kingdom possesses extensive food reserves, flexible trade relationships, and local leaders capable of organizing irrigation repairs without provoking conflict. Although living standards decline temporarily, the society adapts. The neighboring kingdom enters the drought already burdened by political rivalries, unequal access to farmland, and dependence upon a single vulnerable water source. The same environmental stress now produces food shortages, rising prices, migration unrest, and eventually institutional failure. The climate is nearly identical. the societies are not. This principle appears repeatedly throughout both ancient and modern history. Scholars often describe climate as a stress multiplier rather than a sole cause. It magnifies existing weaknesses. It exposes systems already operating close to their limits. It transforms manageable problems into interconnected crises. One of the clearest examples involves food distribution. A poor harvest does not automatically create famine. If transportation networks function effectively, grain can be moved from regions with surplus production. If governments maintain adequate reserves, shortages may be temporary. If trade routes remain open, imports can compensate for local failures. Only when several of these mechanisms begin failing together does widespread hunger become likely. The archaeological record offers numerous hints of these complex interactions. Some cities continue importing luxury goods long after local agriculture begins struggling, suggesting that trade remains active even under environmental pressure. Others maintain monumental construction, despite declining rural populations, indicating that political priorities sometimes remain unchanged, even as economic foundations weaken. These contradictions remind researchers that human societies rarely respond in perfectly rational or uniform ways. Leadership matters. Communities with capable administrators often organize large-scale irrigation projects, redistribute food, or coordinate migration more effectively than fragmented political systems. Conversely, rulers focused primarily on preserving their own authority may ignore growing environmental problems until options become severely limited. Unfortunately, archaeology seldom preserves direct evidence of political decision-making. Broken pottery survives, conversations do not. Researchers therefore reconstruct ancient governance indirectly through settlement patterns, administrative records where available construction activity, and changing material culture. The evidence remains incomplete. No single explanation fully accounts for every historical transformation. Conflict introduces another layer of complexity. Environmental pressure does not automatically cause war. History provides many examples of neighboring communities cooperating during difficult periods through trade-shared water management or negotiated migration. Yet competition becomes more likely when valuable resources grow scarce. Pastures supporting livestock shrink. Reliable springs become increasingly important. Fertile floodplains attract growing populations. Disputes that might once have been settled peacefully now carry greater consequences. Climate changes the stakes. Human beings decide the outcome. Recent research increasingly emphasizes this distinction, because earlier interpretations sometimes portrayed environmental change as an unstoppable force sweeping civilizations aside regardless of human agency. The archaeological evidence paints a subtler picture. Some societies respond creatively, others respond poorly. Many display both strengths and weaknesses simultaneously. One fascinating example concerns agricultural diversification. Communities relying heavily upon a single staple crop often prove more vulnerable than those cultivating multiple plants, adapted to different conditions. Drought-resistant cereals, legumes capable of enriching soils, orchards producing fruit during varying seasons, and mixed livestock herds together create resilience unavailable to highly specialized agricultural systems. Diversity becomes a form of insurance. The same principle applies economically. Settlements participating in broad trade networks frequently weather localized environmental stress more successfully than isolated communities. Crafts mining, fishing, and animal husbandry supplement farming, reducing dependence upon any one resource. Yet expanding trade also creates dependence upon distant stability. If several regions encounter environmental difficulties simultaneously, those networks become strained. Strength and vulnerability often emerge from the same source. Another increasingly important field of study examines social inequality. Ancient societies are rarely uniform. Some households possess extensive land, livestock, and stored grain. Others survive harvest to harvest with little reserve. During favourable years, these differences remain significant but manageable. During prolonged environmental stress, they become far more consequential. Wealthier families purchase food or relocate more easily. Poorer households exhaust their options quickly. Migration patterns recovered through archaeology sometimes suggest that environmental crises affect different social groups in very different ways. The climate changes equally. Its consequences do not. Disease may also contribute, though direct evidence remains limited. Malnutrition weakens immune systems. Reduced water quality increases exposure to pathogens. Crowded urban environments facilitate transmission once illness appears. Scholars continue debating how frequently disease interacts with ancient climate shifts, because skeletal evidence alone cannot always identify specific outbreaks. Still, modern epidemiology suggests these connections are plausible. Environmental stress rarely remains confined to agriculture. It spreads through every aspect of society. One lesser-known but increasingly influential idea concerns information itself. Successful adaptation requires recognizing long-term environmental trends. This is surprisingly difficult. Human beings naturally interpret recent experience more strongly than gradual change unfolding across centuries. If several favorable harvests interrupt a longer drying trend, optimism quickly returns. Communities postpone expensive adaptations because immediate conditions appear to improve. Modern psychology describes similar tendencies today. Ancient societies almost certainly experienced them as well. No farmer possesses access to thousand-year climate records. Every decision is made using limited personal memory combined with inherited tradition. This limitation helps explain why adaptation sometimes arrives too slowly. The changing climate is visible only when viewed across many generations. Individuals live only one. Perhaps the most remarkable lesson emerging from modern archaeology is how often civilizations survive far longer than early researchers expected. Instead of collapsing suddenly after one environmental shock, many societies persist through decades or centuries of mounting difficulty. They reorganize economies, shift settlement patterns, develop new farming methods, expand trade, modify political institutions. Migration becomes adaptation rather than failure. Transformation replaces disappearance. Even where famous cities are eventually abandoned, people themselves often continue living nearby or relocate into regions offering better opportunities. Civilization changes shape, it rarely simply ends. Standing among ancient ruins today, it is tempting to imagine that the silent stones represent inevitable failure. The evidence suggests something different. Those ruins record countless decisions made under conditions of extraordinary uncertainty. Some choices succeed, others do not. The climate places unprecedented pressure upon the world's earliest complex societies, but their ultimate fate depends equally upon leadership, cooperation, innovation, geography, and chance. There is no single culprit. There is no single solution. Only the intricate relationship between human ambition and an environment that continues changing whether civilizations are prepared or not. That relationship leaves behind mysteries still waiting beneath the earth, where abandoned settlements preserve clues to choices whose consequences continue echoing across thousands of years. Not every mystery buried beneath the earth is a forgotten palace or a hidden tomb. Some of the greatest mysteries are empty spaces. A village that should have continued growing simply stops. A city once connected to thriving trade routes gradually falls silent. Hundreds of houses remain standing for a time, yet no new generations rebuild their roofs or repair their walls. The people leave so gradually that the streets preserve no sign of violence, no great fire, no battlefield, and no monument marking the final day. Archaeologists often find absence more difficult to explain than destruction. A burned city tells part of its own story. An abandoned one asks far more complicated questions. One such puzzle appears repeatedly across regions affected by long-term environmental change. Excavations uncover settlements that remain occupied for centuries, sometimes even millennia, before entering periods of slow decline. Pottery styles evolve normally. Trade continues. Children are buried in family cemeteries. Agricultural tools remain in use. Then, almost imperceptibly, the rhythm changes. Fewer houses are repaired. Public buildings receive less attention. Imported goods become increasingly scarce. Workshops fall quiet. Eventually, the settlement disappears from the archaeological record altogether. The temptation is to search for a dramatic explanation. Perhaps invaders arrived. Perhaps disease swept through the population. Perhaps famine emptied the streets in a single desperate season. Yet the evidence often refuses to support any one of these possibilities. Instead, researchers encounter something more elusive, a community that simply loses its reason to remain where it is. This pattern becomes especially visible in regions where changing water systems reshape entire landscapes. Across parts of Southwest Asia, archaeologists have documented numerous settlements whose decline appears closely connected with shifting river channels. Rivers are living systems. They carry enormous quantities of sediment, constantly reshaping their own courses. Floods carve new paths while abandoning older ones. Over centuries, a settlement built beside a thriving river may find itself kilometers away from dependable water. To modern observers, relocation seems obvious. To ancient communities, the decision is anything but simple. Entire generations invest their labor in houses, temples, storage buildings, irrigation canals, orchards, and roads. Religious traditions become attached to particular landscapes. Ancestors are buried nearby. Every stone carries memory. Leaving means abandoning history itself. What survives in the archaeological record suggests that people often resist relocation until environmental change becomes impossible to ignore. This gradual resistance creates one of archaeology's most fascinating signatures. Instead of moving all at once, settlements contract. Outer neighborhoods disappear first. Families concentrate closer to remaining water supplies. Public spaces shrink. Only after decades of adaptation does complete abandonment finally occur. The city dies slowly. Another enduring mystery concerns so-called ghost settlements scattered across the margins of ancient agricultural zones. Many of these communities flourished during relatively favorable climatic periods before being deserted as rainfall declines. Modern satellite imagery frequently reveals traces of ancient field systems extending far beyond landscapes currently capable of supporting cultivation. Stone walls remain. Terraces survive. Canals leave faint lines visible from space. The farms themselves have long vanished. These discoveries remind researchers that today's landscapes cannot always be used to judge the past. Places now considered barren once supported thriving populations. The evidence preserved beneath the soil often tells a radically different story from the scenery visible above it. One particularly intriguing mystery involves the disappearance of certain trade networks. Trade leaves surprisingly durable evidence. Obsidian from volcanic regions appears hundreds of kilometers from its source. Marine shells reach inland settlements. Copper tin precious stones, pigments, and ceramics travel remarkable distances. Archaeologists reconstruct these exchanges by tracing the geological origins of materials found far from where they naturally occur. Then in some regions the connections weaken. Imported goods become rarer. Exotic materials disappear from ordinary households. Luxury items concentrate among smaller elites or vanish entirely. Scholars still debate exactly why these networks contract. Environmental pressure likely plays an important role. Communities struggling simply to feed themselves possess fewer resources for long-distance exchange. Yet political instability, changing migration routes, technological shifts, and evolving economic priorities also influence trade. No single explanation fully accounts for every pattern. One of the greatest archaeological mysteries concerns settlements that appear to recover after periods of environmental stress, only to be abandoned centuries later for different reasons. History is rarely linear. A drought weakens one community. Several wetter decades allow rebuilding. Population increases once more. Another climatic fluctuation arrives generations later. Each cycle leaves its mark upon architecture, agriculture, and social organization. Without precise dating methods, these repeated occupations can appear deceptively simple. Modern radiocarbon analysis has transformed this understanding. Sites once believed to represent single episodes of collapse now reveal multiple phases of abandonment and renewal stretching across centuries. The landscape breathes. People leave. People return. The cycle repeats until conditions finally change beyond recovery. Ancient DNA has added another unexpected dimension to these mysteries. For decades, archaeologists sometimes assumed abandoned settlements represented populations that had disappeared entirely. Genetic evidence increasingly challenges that assumption. The descendants of those communities often survive elsewhere. Their ancestry appears in neighboring regions. Languages evolve. Cultures merge. Traditions continue under different names. Civilizations vanish. People rarely do. This distinction reshapes the meaning of archaeological silence. An empty city does not necessarily represent extinction. It may instead record transformation. One lesser-known mystery involves ancient wells. Across many excavated settlements, wells deepen over time. Each generation extends the shaft farther below the surface. Initially, this seems a straightforward response to falling groundwater. Yet in some locations, deepened wells are later abandoned even though technically usable. Researchers propose several possibilities. Groundwater may have become increasingly saline. Maintenance could have exceeded available labour. Nearby populations may simply have relocated toward more dependable rivers. The evidence remains incomplete. Even something as seemingly simple as a well can preserve unanswered questions lasting thousands of years. The same uncertainty surrounds changing burial practices. In certain regions, cemeteries shrink alongside settlements. Elsewhere, burial traditions shift entirely. Some archaeologists suggest these changes reflect migration. Others emphasize evolving religious beliefs or political organization. Environmental stress may contribute indirectly by encouraging movement or altering community identity. Again, certainty proves elusive. Archaeology rarely provides perfect answers. It offers probabilities built from fragments. One broken pot, one abandoned canal, one layer of wind-blown dust, one forgotten pathway revealed beneath satellite imagery. Together they suggest stories that no surviving written record ever describes. Perhaps the greatest mystery of all is psychological. How do people recognize that the world familiar to their ancestors is disappearing? There is no excavation capable of uncovering individual emotions. No inscription records every doubt felt by a farmer watching familiar springs fail. No pottery fragment preserves the conversations between neighbors deciding whether to stay or leave. Yet those moments almost certainly shape history as profoundly as any battle. Someone is always the first to suggest abandoning the village. Someone insists the rains will return. Someone chooses to remain. Someone quietly departs before dawn. These decisions, repeated across countless households over generations, alter the demographic map of entire continents. The archaeological record captures only the consequences. The choices themselves are lost. Standing today among abandoned settlements reclaimed by sand forest or grassland, modern visitors often experience an eerie sense of stillness. Stone walls remain, doorways still frame empty skies. Paths worn smooth by thousands of footsteps lead nowhere. Silence fills places once alive with conversation, children, animals, and harvest celebrations. Yet beneath that silence lies a remarkable truth. These ruins are not merely monuments to collapse. They are monuments to adaptation, resilience, uncertainty, and survival. They remind us that history is rarely erased. It is rewritten, sometimes so gradually that only the earth itself remembers every step of the transformation. When the climate changes, survival does not belong only to the strongest. More often it belongs to the most adaptable. History tends to celebrate great cities, towering monuments, and powerful kingdoms because they leave behind impressive ruins. Yet many of the communities that endure the environmental transformations of the ancient world leave far subtler traces. Their success is measured not in massive stone architecture, but in their willingness to alter long-established ways of living before circumstances make change unavoidable. The archaeological record is filled with these quieter victories. While some large urban centres gradually contract under mounting environmental pressure, smaller settlements often display remarkable flexibility. Instead of depending upon one dominant crop, they cultivate several. Instead of relying exclusively on agriculture, they combine farming with herding, fishing, hunting, and seasonal gathering. Instead of remaining permanently tied to one location, they maintain patterns of movement that allow them to respond to changing rainfall. These choices rarely attract attention in traditional histories, yet they may explain why certain populations survive while others struggle. One of the clearest examples comes from pastoral societies. For much of human history, mobile herders have sometimes been viewed as less complex than settled agricultural civilizations. Modern archaeology paints a very different picture. Pastoral communities often possess sophisticated environmental knowledge accumulated over countless generations. They understand seasonal grazing cycles, hidden springs, drought-resistant vegetation, and migration routes stretching across vast territories. Mobility itself becomes a technology. A farming village depends upon making one landscape productive. A pastoral society depends upon knowing many landscapes well enough to move between them. As rainfall patterns shift, this flexibility proves invaluable. Herds can be redirected toward regions where grass remains available. Temporary camps replace permanent settlements during especially dry years. Social networks connecting distant groups allow information about water sources to spread rapidly. This does not mean pastoral life is easy. Livestock require enormous quantities of forage and water. Prolonged drought can devastate herds just as surely as it destroys crops. Yet mobility gives herders options unavailable to communities whose entire economy depends upon fixed fields and irrigation systems. Across parts of Africa, Southwest Asia, and Central Asia, archaeological evidence increasingly suggests that pastoralism expands during periods when farming becomes more difficult in marginal environments. The landscape itself encourages flexibility. Agricultural innovation also plays a crucial role. Ancient farmers are anything but conservative when survival is at stake. Excavations reveal changing combinations of crops over time. Drought-tolerant cereals become more common where rainfall declines. Legumes capable of improving soil fertility appear alongside staple grains. Fruit trees requiring different growing conditions diversify food supplies. Some communities adjust planting schedules to match shifting seasons. These changes may appear modest. Collectively, they represent centuries of experimentation. Every successful adaptation begins with someone willing to try something different despite uncertainty. Seed selection offers another remarkable example. Long before modern genetics, farmers quietly reshape the plants upon which civilization depends. Saving seeds from crops surviving difficult conditions gradually encourages traits favoring drought resistance, earlier maturation, or improved tolerance of poor soils. Generation after generation, human observation guides biological evolution. The process is slow. Its effects are profound. Water management continues evolving as well. Instead of simply expanding irrigation, some communities become more efficient in using limited supplies. Terraces reduce runoff on hillsides. Small check dams slow seasonal streams, allowing water to soak into surrounding soils. Stone-lined channels minimize seepage. Underground storage preserves water against evaporation. Many of these techniques remain in use today. Their survival reflects practical success tested across centuries. Trade becomes another powerful survival strategy. As environmental conditions diverge between neighbouring regions, exchange networks allow communities to compensate for local shortages. Grain travels toward drought-affected settlements. Salt moves from arid regions into wetter agricultural zones. Livestock, textiles, metals, and pottery continue circulating even when harvests fluctuate. These networks are more than economic systems. They become lifelines. A poor harvest no longer guarantees disaster if neighbouring communities enjoy better conditions. Of course, this dependence introduces new vulnerabilities. Trade functions only while routes remain secure and partners retain surplus resources. Still, for many societies, expanding exchange proves more effective than attempting complete self-sufficiency. One particularly fascinating adaptation concerns architecture. Buildings evolve alongside climate. In hotter, drier regions, houses increasingly emphasize thick walls capable of moderating indoor temperatures. Courtyards improve air circulation while reducing direct exposure to intense sunlight. Storage spaces become larger as preserving harvests grows more important. Roof designs change according to rainfall patterns. Even settlement layouts reflect environmental knowledge. Narrow streets create shade. Orientation captures prevailing winds. Construction materials exploit local thermal properties. Ancient builders rarely separate architecture from climate. They understand intuitively what modern sustainable design increasingly rediscovers. Social organization changes as well. Communities facing repeated environmental uncertainty often strengthen cooperative labor systems. Shared irrigation maintenance, communal grain storage, and collective management of grazing lands reduce risks impossible for individual households to handle alone. Cooperation becomes an adaptive resource. Yet cooperation requires trust. Where inequality grows severe or political authority weakens, maintaining these shared systems becomes increasingly difficult. Scholars still debate exactly how environmental stress influences social cohesion. Some evidence suggests hardship encourages collaboration. Other examples indicate rising competition. Both responses appear throughout history. Human behavior remains as variable as climate itself. Migration, once viewed primarily as evidence of failure, increasingly appears as another successful adaptation. Families relocating toward more reliable environments carry knowledge, technology, languages, and traditions into new regions. Their arrival stimulates innovation, as different communities exchange ideas developed under varying environmental conditions. Civilizations become more connected precisely because people refuse to remain trapped in deteriorating landscapes. Genetic research reinforces this understanding. Ancient populations, once assumed to have disappeared, instead contribute ancestry to later societies across remarkable distances. Cultural traditions merge. Agricultural practices spread. New political systems emerge from interactions between migrating and established communities. Survival often depends less upon preserving old identities unchanged than upon creating new ones. One lesser-known example involves food itself. Archaeobotanical studies reveal surprisingly diverse ancient diets. Wild fruits, nuts, edible grasses, fish, shellfish, birds, insects in some regions, and numerous cultivated plants supplement staple grains. During environmental stress, these alternative resources become increasingly important. Communities possessing broad ecological knowledge enjoy greater resilience than those relying upon narrow agricultural specialization. Biodiversity protects civilization. This lesson echoes across millennia. Modern climate scientists frequently study ancient adaptations not because they offer perfect solutions, but because they reveal enduring principles. Flexibility matters, diversity matters, local knowledge matters, cooperation matters. No single strategy guarantees survival. Instead, resilience emerges through overlapping systems capable of absorbing unexpected shocks. Perhaps the greatest survivors of all are not particular cities or kingdoms, but ideas. Agricultural knowledge passes from generation to generation even after settlements disappear. Irrigation techniques spread between cultures. Crop varieties developed thousands of years ago continue feeding billions today. The descendants of ancient migrants carry inherited adaptations into entirely new environments. Civilization evolves because people learn. The monuments most admired by later generations often belong to societies eventually transformed or abandoned. The quieter achievements belong to those who recognize change early enough to adapt. Their legacy is less visible, yet it proves infinitely more durable. While abandoned cities remind us how civilizations struggle, surviving communities remind us why humanity endures. Again and again, the ancient world demonstrates that environmental change does not simply eliminate societies, it reshapes them. Some disappear from familiar landscapes only to flourish elsewhere. Others abandon old technologies while inventing new ones. Still others preserve fragments of knowledge that later civilizations inherit without ever fully realizing their origins. The climate changes. The landscape changes. Civilization changes with it. And through every transformation, human beings continue carrying forward the remarkable ability that has defined the species from the beginning, not merely the ability to build, but the ability to begin again. Long after the rivers change course and the fields fall silent, the memory of those transformations continues to travel. It no longer moves through canals or trade routes. Instead, it passes from one generation to the next as stories. A great flood that covered the land. A terrible drought that forced entire peoples to wander. A fertile homeland lost beyond the horizon. A time when the seasons no longer behaved as they once had. These stories evolve with every retelling shaped by religion, culture, and imagination, yet they often preserve faint echoes of environmental events that profoundly affected ancient communities. Separating memory from myth is one of archaeology's greatest challenges. Modern researchers approach these traditions with careful balance. Myths are not treated as literal historical documents, but neither are they dismissed as meaningless fiction. They frequently preserve cultural memories, symbolic truths, or fragments of real experiences transformed over centuries of oral transmission. The difficulty lies in determining where environmental history ends and storytelling begins. No single explanation fully accounts for these ancient narratives. Yet some intriguing connections continue to emerge. Flood stories appear across an astonishing number of civilizations. Mesopotamian traditions describe overwhelming waters sent by divine forces. Ancient Hebrew texts preserve another famous account of a catastrophic flood. Greek mythology tells of Deucalion surviving a world-consuming deluge. Stories of destructive floods also appear across parts of South Asia, East Asia, Oceania, and the Americas. For centuries, some people search for evidence of one single global flood. Modern geology does not support such an interpretation. Instead, scientists recognize that large floods have occurred repeatedly in different places throughout history. Rivers overflow catastrophically. Coastal storms drive seawater far inland. Glacial lakes burst through natural dams. Tsunamis reshape shorelines. Rising sea levels after the last ice age permanently inundate enormous areas once occupied by humans. Communities experiencing such events naturally remember them. As generations pass, local disasters often become universal stories. This process is familiar even today. A historical event affecting one region may eventually be remembered as shaping the entire world of those who experienced it. The same pattern likely influenced many ancient traditions. The gradual flooding of coastal plains following the end of the Ice Age provides one particularly compelling example. Around 20,000 years ago, global sea levels stand more than 100 meters lower than today, because immense quantities of water remain locked within continental ice sheets. As the climate warms, glaciers melt steadily for thousands of years. The consequences are extraordinary. Vast coastal landscapes disappear beneath rising oceans. River valleys become estuaries. Plains connecting islands to continents vanish forever. Modern archaeological discoveries increasingly reveal evidence of prehistoric human occupation beneath today's seas. Entire coastlines where early communities once hunted, gathered, and perhaps even farmed now lie underwater. What survives in the record suggests that this flooding unfolds gradually over many generations rather than as one sudden event. Yet gradual change can still inspire powerful cultural memory. A family may notice the shoreline retreating only slightly during one lifetime. After 20 generations, however, the sea occupies an entirely different landscape. The homeland of distant ancestors has literally disappeared. Stories become the only bridge connecting descendants to places that no longer exist. Drought leaves different kinds of memories. Unlike floods, drought rarely creates dramatic visual endings. Instead, it produces long periods of uncertainty. Harvests become unreliable. Animals disappear. Rivers shrink. Migration begins. These experiences may later survive in traditions describing wandering ancestors, promised lands, sacred rivers, or divine tests associated with scarcity. Scholars remain cautious when drawing such connections. The evidence is rarely direct. Oral traditions evolve over centuries, absorbing influences from political change, religious development, and cultural exchange. Still, the persistence of environmental themes across widely separated civilizations remains striking. Water appears repeatedly as both life and danger. Fertile gardens become symbols of lost perfection. Deserts represent hardship and transformation. Mountains preserve refuge during times of catastrophe. These recurring images reflect humanity's enduring relationship with changing landscapes. One fascinating area of research examines sacred geography. Many ancient religious centers develop around springs, rivers, lakes, or mountains associated with reliable water supplies. Such locations naturally acquire spiritual significance because survival depends upon them. As climates change, these places often retain cultural importance even when their environmental role diminishes. A spring may shrink, a river may shift course. The sacred tradition continues. Religion preserves memory long after ecology changes. Rock art offers another remarkable window into ancient perception. Across the Sahara, paintings and engravings document environments radically different from today's desert. Boats glide across lakes now replaced by sand. Herds of cattle graze lush grasslands. Crocodiles and hippos inhabit waters that vanished thousands of years ago. These images are not myths. They are observations. Yet for later generations living in the expanding desert, such scenes must have appeared almost legendary. Imagine growing up surrounded by dunes while hearing stories of ancestors who travelled by boat across broad lakes in the very places where sand now stretches to every horizon. Reality gradually becomes mythology. The climate itself creates legend. Astronomical observations may also preserve environmental memory in unexpected ways. Many early societies carefully record seasonal appearances of stars because these celestial events coincide with agricultural cycles. Rising stars announce planting seasons. Constellations mark expected floods or harvests. When climate alters the timing or reliability of those seasons, traditions surrounding the heavens sometimes become disconnected from the environmental realities that originally gave them meaning. The stars remain unchanged. The Earth does not. This subtle separation fascinates historians because it reveals how cultural systems developed under one climate may persist into another. One lesser-known example involves ancient place names. Rivers now dry may still bear names referring to flowing water. Deserts contain locations whose names suggest forests or marshes. Such linguistic clues occasionally preserve evidence of landscapes transformed long before written history. Language becomes another archive. Words outlive ecosystems. Genetic memory adds yet another layer. Communities migrating in response to environmental change carry not only stories, but inherited adaptations, agricultural knowledge, and cultural practices into new regions. Later civilizations may preserve traditions whose original environmental context has long disappeared. A ritual developed beside one river survives centuries later beside another. A farming calendar created under wetter conditions continues after rainfall patterns have changed. Culture often proves more durable than climate. Scholars still debate how much weight should be given to mythological evidence when reconstructing ancient environmental history. Some researchers emphasize symbolic interpretation almost exclusively. Others argue that oral traditions deserve greater consideration alongside geological and archaeological evidence. Most agree upon one essential principle: myths should neither be accepted literally nor dismissed entirely. Instead, they represent cultural landscapes requiring interpretation just as carefully as physical ones. The people experiencing ancient climate shift rarely understand atmospheric circulation orbital cycles or changing ocean temperatures. They explain transformation through the language available to them. Gods, heroes, sacred floods, lost gardens, wandering ancestors. Modern science offers different explanations. The human experience remains remarkably similar. Standing beside a shrinking river, watching familiar fields produce smaller harvests, seeing neighbours quietly depart for distant lands, these realities require meaning regardless of the century in which they occur. Stories provide that meaning. Long after the environmental crisis itself has passed, those stories continue travelling through time. Sometimes they become scripture, sometimes folklore, sometimes legend. Occasionally beneath layers of symbolism and imagination, they preserve faint but genuine echoes of the climate shifts that reshaped the first societies, reminding future generations that landscapes change, civilizations adapt, and memory often survives where monuments do not. For thousands of years, the evidence remained scattered across the planet, a layer of dust buried beneath a dried lake in Africa, ancient pollen trapped in the mud at the bottom of a forgotten marsh in Europe, a stalagmite growing silently inside a cave in China, tree rings preserved in the high mountains of North America, broken irrigation canals disappearing beneath desert sand in Southwest Asia. Each fragment revealed only a tiny part of the story. Alone, none could explain why so many early societies rose during one period of history and struggled during another. Only in recent decades, as scientists from many different disciplines began comparing their discoveries, did these isolated clues begin forming a coherent picture of one of humanity's greatest environmental turning points. The modern reconstruction of ancient climate is itself an extraordinary story. It depends upon collaboration between archaeologists, geologists, climatologists, botanists, chemists, geneticists, hydrologists, and satellite engineers. No single field possesses enough information on its own. Understanding the relationship between climate and civilization requires assembling evidence collected across continents and preserved in remarkably different forms. The result is a new way of seeing the ancient world. Instead of viewing civilizations as isolated achievements rising independently from their surroundings, researchers increasingly understand them as parts of larger environmental systems. Rivers, forests, oceans, monsoons, mountain snowpacks, and even microscopic organisms become active participants in the human story. Technology has transformed this understanding at an astonishing pace. Satellite imagery now reveals landscapes invisible from the ground. Across the Arabian Peninsula and the Sahara radar systems penetrate dry sand to expose buried river channels, carved when rainfall was far more abundant than today. These ancient waterways often lead directly toward archaeological sites that once puzzled researchers. Settlements appearing isolated in modern deserts suddenly make perfect sense. They were never built in deserts at all. They stood beside rivers that disappeared thousands of years later. High-resolution satellite data also identifies abandoned field systems stretching across hillsides, forgotten irrigation canals hidden beneath modern agriculture, and ancient road networks connecting settlements long erased from the surface. The landscape still remembers, Technology simply allows people to read its memory more clearly. Ground-penetrating radar offers another remarkable advance. Without disturbing the soil, researchers detect buried walls, streets, foundations, and canals extending beneath modern towns or open countryside. Entire settlements emerge digitally before excavation even begins. Some of the most exciting discoveries occur where environmental reconstruction and archaeology intersect. A buried river identified from satellite imagery leads to an unexplored settlement. Excavation reveals farming communities exactly where paleoclimate evidence predicts favorable conditions once existed. Independent lines of evidence strengthen one another. Confidence grows. Chemical analysis has become equally important. Tiny samples extracted from ancient bones reveal dietary changes across generations. Different forms of carbon and nitrogen preserved within human skeletons indicate shifts between agricultural crops, wild foods, and animal protein. Researchers no longer rely solely upon pottery or architecture. Human bodies themselves preserve environmental history. Teeth provide particularly valuable information. The chemical composition of tooth enamel reflects water and food consumed during childhood. Because enamel does not continually remodel like bone, it permanently records where individuals spend their early years. Ancient migration suddenly becomes visible. A person buried in one valley may have grown up hundreds of kilometers away. Large-scale movements once invisible to archaeology emerge through chemistry. Genetic research has revolutionized the field even further. Only a generation ago, many questions about ancient population movements seemed impossible to answer. Today, ancient DNA extracted from human remains reveals relationships between communities separated by vast distances and long spans of time. The results are frequently surprising. Populations previously assumed unrelated often share common ancestry. Communities believed to have disappeared contribute genetically to later civilizations. Migration proves far more widespread than earlier historians imagined. Climate change does not simply empty landscapes, it redistributes people. Artificial intelligence and advanced computing now assist researchers by identifying patterns impossible to detect manually. Massive climate datasets can be compared with archaeological chronologies spanning thousands of years. Statistical models explore relationships between rainfall settlement density, agricultural productivity, and migration. Importantly, these tools do not replace traditional archaeology. They generate new questions. Fieldwork still provides the essential evidence. A computer may suggest where an ancient river once flowed. Only excavation confirms whether people actually lived beside it. One particularly exciting area of study examines resilience rather than collapse. Earlier generations of researchers often focused upon why civilizations failed. Modern scholarship increasingly asks a different question. Why did some communities survive? This subtle change has produced important insights. Resilient societies frequently display diversity, diverse crops, diverse economies, flexible political structures, broad trade networks, strong local environmental knowledge. Rather than depending upon one solution, they develop overlapping strategies capable of absorbing unexpected change. The lesson extends well beyond archaeology. Modern climate science continues drawing inspiration from ancient experience. Researchers studying contemporary drought, water management, and agricultural sustainability frequently examine prehistoric adaptations for practical insights. Terrace farming, developed thousands of years ago, still reduces erosion. Traditional irrigation methods sometimes outperform modern systems under particular environmental conditions. Ancient seed varieties preserved by farming communities occasionally possess valuable resistance to drought or disease. History becomes a laboratory, not because the past provides perfect answers, but because it records countless experiments already tested under real environmental pressure. Scholars remain careful about direct comparisons. The modern world differs profoundly from ancient civilizations. Global trade, industrial technology, scientific forecasting, and modern infrastructure create possibilities unavailable to early societies. At the same time, certain realities remain unchanged. Agriculture still depends upon climate. Water remains essential. Environmental stability continues supporting economic and political systems. No civilization, ancient or modern, exists independently of the natural world. The evidence remains incomplete, and new discoveries regularly reshape understanding. Fresh archaeological sites appear every year. Previously unknown cave records extend climate chronologies farther into the past. Improved dating techniques refine timelines once considered settled. Science itself continues adapting. Perhaps that is the most fitting parallel. Just as ancient societies constantly adjusted to changing landscapes, modern researchers continually revise their understanding in response to new evidence. Knowledge evolves. Certainty remains provisional. This humility distinguishes the stronger scientific work. No single explanation fully accounts for every ancient transformation. No universal formula predicts how every society responds to environmental stress. The ancient world resists simple narratives because human history has always been more complicated than any one cause can explain. Standing today above a buried settlement revealed through satellite imagery, an archaeologist may see only faint outlines beneath the soil. To the people who once lived there, it was a world. Children played in its streets. Farmers walked to nearby fields. Water flowed through canals now invisible from the surface. Neighbors shared harvest celebrations beneath skies that seemed as dependable as tomorrow. The climate changed. The settlement vanished. Yet through science, fragments of that forgotten world return once more into view, reminding humanity that landscapes never truly erase their history. They simply wait for someone to learn how to read it. Every civilization begins with an assumption. The assumption is rarely spoken aloud because it seems too obvious to require explanation. The rivers will return next year. The rains will arrive in their season. The fields that fed parents will also feed children. Mountains will continue releasing snowmelt into the valleys below. Forests will remain where they have always stood. Lakes will continue reflecting the same skies. These expectations become so deeply woven into daily life that they disappear beneath routine. The earliest societies of the ancient world are no different. Their achievements are extraordinary. They domesticate plants and animals. They transform floodplains into productive farmland. They build canals stretching across dry landscapes. They invent writing, organized government, monumental architecture, long-distance trade, and increasingly complex systems of knowledge. Looking back across thousands of years, it is tempting to see these accomplishments as inevitable steps in humanity's progress. The archaeological record tells a more humbling story. Civilization is never inevitable. It depends upon countless relationships that remain invisible while they continue functioning. Soil forms slowly through biological and geological processes. Rivers carry nutrients from distant mountains. Pollinating insects move silently through flowering crops. Seasonal winds transport moisture across continents. Ocean currents regulate temperatures far beyond the horizon. People notice these systems most clearly only after they begin changing. That realization reshapes how the earliest societies are understood. Their story is not simply one of success followed by failure. It is a story of continual negotiation with an environment that never stands completely still. During favorable centuries, agriculture expands. Villages become towns. Towns become cities. Trade networks connect distant cultures. Population grows. When environmental conditions gradually shift, those same societies do not immediately collapse. They adapt. They reorganize. They migrate. They experiment. Some succeed longer than others. Some transform so completely that later generations barely recognize the continuity linking old communities to new ones. This may be the greatest lesson preserved beneath the ruins. Civilizations are far more flexible than early historians often imagined. At the same time, they're far more dependent upon environmental stability than they themselves usually realize. Modern archaeology increasingly replaces dramatic stories of mysterious disappearances with quieter narratives of gradual transformation. A famous city may decline, its people settle elsewhere, agricultural methods evolve, trade routes shift, political authority changes, languages absorb new influences. The civilization continues, though, no longer in the form familiar to its ancestors. History rarely ends. It changes direction. One particularly striking realization emerges from comparing societies across different continents. Communities separated by thousands of kilometers often confront remarkably similar challenges despite never communicating with one another. Farmers in Southwest Asia deepen irrigation canals. Communities in North Africa follow retreating water sources. Settlements in the Indus region reorganize around changing rivers. Elsewhere, people diversify crops, expand trade, or adopt more mobile ways of life. Different cultures, different landscapes, remarkably similar responses. This convergence reminds us that environmental change is not merely a local problem, but a recurring feature of human existence. Generation after generation, people inherit worlds slightly different from those known by their grandparents. Most changes remain small enough to escape immediate notice. Occasionally, they accumulate into transformations that redefine entire civilizations. The climate shift explored throughout this story belongs to that second category. It does not erase humanity. It reshapes humanity. It encourages movement across continents. It alters economies. It changes political structures. It transforms religious traditions. It influences technology. It redirects history without ever becoming the only force guiding events. Scholars still debate many details. Exactly how severe were particular droughts? How quickly did monsoon systems weaken in different regions? What role did earthquakes, river migration, conflict disease, or social inequality play alongside environmental stress? The evidence remains incomplete. New discoveries continue refining old conclusions. That uncertainty is not a weakness. It is one of science's greatest strengths. Each excavation, sediment core, genetic analysis, and satellite survey adds another piece to a puzzle far larger than any individual researcher can solve. Perhaps the most profound change has occurred not in archaeology itself, but in perspective. Earlier generations often treated humanity as separate from nature. Modern research increasingly demonstrates the opposite. Cities rise within ecosystems. Economies depend upon rainfall. Political systems rely upon agriculture. Culture develops within landscapes that shape opportunity as much as human ambition shapes the landscape. The boundary between civilization and environment proves far less distinct than once imagined. Standing among ancient ruins today, visitors frequently admire impressive architecture while overlooking the surrounding geography. Yet the fields beyond the walls, the vanished wetlands, the dried riverbeds, and the distant mountains supplying seasonal water were every bit as important as the buildings themselves. Without them, the monuments would never have existed. The climate shift that challenged the first societies therefore leaves a legacy extending far beyond antiquity. It teaches that resilience is neither endless nor absent. It grows from diversity, cooperation, adaptation, and careful observation of the natural world. It reminds us that prosperity often depends upon conditions so familiar they become nearly invisible. Most importantly, it reveals that the greatest achievements of civilization are not measured only by what people build. They are also measured by how wisely they respond when the world around them begins to change. The first societies did not possess satellites, climate models, or scientific instruments capable of measuring atmospheric circulation. They relied instead upon experience, inherited knowledge, careful observation, and collective memory. Sometimes those tools proved sufficient. Sometimes the changes unfolding around them exceeded anything earlier generations had known. Even then humanity endured. Cities disappeared. People did not. Empires faded, communities survived, landscapes transformed, new civilizations eventually rose upon the foundations left behind. The story of the first societies is therefore not ultimately about collapse. It is about continuity. It is about a species learning, often painfully, that stability is precious precisely because it is never permanent. Every abandoned village, every forgotten canal, every dried lake bed and silent ruin carries the same quiet reminder across thousands of years. Civilization is strongest when it remembers that it has always been part of the living earth, never separate from it. The ancient fields are quiet now. Where farmers once watched the horizon for gathering clouds, grasses sway over buried foundations. Rivers that nourished generations have shifted, narrowed, or disappeared altogether. Lakes that reflected villages exist only as faint outlines beneath desert sand or layers of sediment patiently preserving their memory. The voices that filled those landscapes are long gone, yet their choices remain written across the earth in ways only time could reveal. Looking back across these thousands of years, the story becomes gentler than the ruins first suggest. The first societies are not simply warnings about collapse. They are reminders of resilience, curiosity, and the remarkable willingness of ordinary people to adapt to extraordinary change. Parents planted trees whose fruit they might never taste. Builders repaired canals despite uncertain seasons. Families carried seeds, tools, and traditions into unfamiliar lands, trusting that life could begin again somewhere beyond the next valley. The climate changed as it always has. Rivers wandered, deserts expanded, forest retreated. Yet humanity continued moving with the landscape, learning from it, sometimes resisting it, sometimes accepting it, always shaped by it. Today, archaeologists brush dust from forgotten walls, scientists read ancient rainfall from caves and lake beds, and satellites quietly reveal rivers hidden beneath the sands. Together they restore fragments of worlds that seemed forever lost. Each discovery reminds us that history is rarely erased. It waits patiently beneath our feet, preserved in stone, soil, water, and memory. Perhaps that is the quietest lesson of all. Civilizations may rise with astonishing confidence, believing the world around them will remain unchanged. Time gently proves otherwise, but within every ending lies another beginning carried forward by those willing to adapt, to remember, and to continue. As evening settles over the ancient landscapes, the ruins no longer seem empty. They become part of a much longer conversation between humanity and the earth, a conversation that began long before the first cities and continues long after their walls have fallen silent. The wind still crosses those forgotten plains, the rivers still seek the sea, and somewhere beneath the quiet ground the story of the first societies continues to wait patiently, reminding every generation that even the greatest civilizations are in the end chapters within the far older history of the living world.